ठीक है. बाकी कहाँ रह गए? Okay, so good afternoon everyone. So today we'll be starting a new chapter called solid state. Solid state is over. Okay, so we'll be starting a new chapter called solutions or liquid solutions. But there's two questions which have come up as a doubt from the solid state chapter. So we'll quickly discuss these two first, and then we'll be starting the liquid solutions. So the first question, I'll just read it out. The question is that in a solid AB having NaCl structure. So I have a solid which has a rock salt structure or NaCl structure, which means that anions are forming the FCC lattice and cations are occupying the all octahedral voids, right? The A atoms occupy the corner of the cubic unit cell. In this case, A atoms occupy corner of the unit cell. I'm just writing the data right now. We'll see what part of data interprets what, right? If all the face-centered atoms along one of the axes are removed, then the resultant stoichiometry of the solid is, which means that it is asking for a formula of this ionic crystal, that what it will be if all the atoms along one of the axes are removed, which the axis is passing through face centers, right? So let's first understand what this data means to us. Now, since in NaCl structure I know that the sodium ions occupy all octahedral voids, and octahedral voids are of which lattice? The lattice formed by the Cl minus. It forms the FCC lattice, right? So the chloride ions are forming the face-centered cubic lattice, and in that lattice, in the voids, which are octahedral voids, all octahedral voids are filled by sodium ions, right? Now, just to quick review of the two cases, what is the position of FCC lattice? Like, I mean, any atom or ion or molecule forming FCC lattice, where all it is present? At the corners and center of each faces, right? What is the position of octahedral voids in any FCC? What is the position of octahedral voids, as in, for example, if you have a FCC lattice of, for example, chloride ions. So when you're forming a lattice, so there are like a lot of particles which are there, and there are like a lot of empty spaces in between, so which can be called as voids. There's a specific type of empty space or void which is called octahedral void, which fits certain requirements. So there are certain octahedral voids. So where do we find octahedral voids in an FCC lattice? In any of the FCC lattice? Where do you find them? No, so but if, for example, if the way you describe the position of particles in FCC lattice, like they're at the corners and at the center of the faces, right? So you can allocate a position to the particles in FCC lattice. Similarly, you can also allocate the position of a void in that lattice. So octahedral voids are present they're present at two positions. One is at the centers of each edge. So in FCC, all edge centers have an octahedral void, right? And they're present at the body center. So these are the two distinct positions of the octahedral void in FCC lattice. One is at the center of the whole unit cell, which is also called body center, and second, the center of each edge. So there are 12 edges. Every particle at the edge center contributes 1/4 of its volume. So 12 into 1/4, it will be 3. It will contribute whole of its volume, it will be 4. So FCC, the rank of FCC is 4. The rank of octahedral void should also be 4. So 4 is 4, right? So that's how the case is. Now, let's now come back quickly to the question of this case, where we're talking about some solid which is AB, in which it has mentioned that A is at corners of the unit cell. But A can also be anywhere else. Like, I mean, apart from this is definitely there, but it will also be present at other positions. But at corners, only A is present. Now, out of the two, which one goes to the corner? Cl minus. Out of the two, Cl minus goes to the corner because the FCC lattice particle goes to the corner and face centers. So which mean that A is actually taking up the positions taken by Cl minus in NaCl lattice, which means that in this case A will be forming the FCC lattice and conversely B will be occupying all octahedral voids in FCC. Right? So this is the first analysis of the information which we have here. First thing. Now you have to just imagine this unit cell. So in this unit cell you have a lattice formed by A in which the A atoms will be at corners and face centers. And B particles, since are occupying octahedral voids, they will be present at two positions. One is edge centers and body centers. Okay, so I think we have used this information. Can I remove this? Now, so I have this information, so let's come back to what is being done to this crystal. Let's just read out the statement again. The statement is, if all the face-centered atoms along one of the axes are removed, then the resultant stoichiometry of the solid is. So let's imagine a solid unit cell here, which is a cube. If you're not good with the visualization through a 2D shape from like of a 3D figure from a 2D image here, you can visualize your cubic room and treat it as a cube instead of like a cuboid. Treat it as a completely cube. For example, we are in this room. So, and I think at all the centers, all the students are like come in some sort of this rectangular or cuboid kind of room. Just assume it as a cube which has 4 walls. These are 4 faces, 1 ceiling and 1 floor. These are 2 other faces. So every cube has a 6 faces, in which there are 2 faces which are opposite to each other. For example, there is a face here, there is a face opposite to it, there is a face on the left side, there is a face on the right side, and one on the top and one on the bottom. So now, for example, if I have 2 face centers here, I'm talking about the axis which is passing through a face center, which means this is the axis I'm talking about. All the face center atoms present on this axis are removed. So from one unit cell, out of all 6, 2 face center atoms are removed. Right? Now, so let's calculate the new rank. Do you understand this term rank? Rank is effective number of particle of whatever thing you're talking about, whether it's molecule, atom or ion, per unit cell. Like for example, if I say copper forms FCC lattice, so rank of copper is 4. If copper forms, for example, BCC lattice, rank of copper is 2. It forms simple cubic, the rank is 1, which is an effective number of particle. The same can be taken for the ionic crystals, for example, NaCl. So I have 4 chloride ions, 4 sodium ions, which means I have 4 ion pairs of NaCl. So rank of NaCl is 4. Got it? So now, so I can talk about rank about the individual particle as well. So let's talk about the B. So I have not removed any of the atom of B, so its rank will be 4, right? Earlier it was 4. Why it was 4? Octahedral voids. How many octahedral voids are there in one FCC? 4. It's equal to rank of the lattice, right? A. So original rank of A was 4, but out of it 2 face center atoms have been removed. And how much do they contribute? Half. So it will be 4 minus 1, 3. So now, as per this, the empirical formula of the compound will be A3B4. So got it? So this is the solution A3B4, which is D in this case, in the options given. There is another side to it, which we can also explore quickly in the same question. Should I erase this part? No. other side of it is that let's come back to the same unit cell. Right. So now you have a phase center atom on the top, phase center atom at the bottom, two opposite faces. There is an axis which is passing through it. I have removed all the face centered atoms. I have not removed any other atom. But let's assume a situation where I have just modified the same question to a new case where what I'm saying is I have removed all the atoms falling on the axis passing through face centers or passing perpendicular to a face and through a face center. So now if I say all the atoms, so obviously the face center atoms will definitely be a part of it, they'll be removed, but along with it, the face center, the axis passing through the face center will also pass through the body center. So one of the atom of body center will also be removed in that case if I would have said all the atoms on this axis, but it has specifically said all the face centered atoms falling on this axis passing through face center. So if I've removed all the atoms, then in that case, this is your B and this is A. So one of the B atom would have also been removed from the body center. So now the rank will be, for B, it will be 4 minus 1 into 1. How 1 into 1? I've removed one particle of B and its contribution as of its volume is whole because it's present in the body center. For A, it was 4 initially, I've removed 2A and each particle contributes half of its volume. So which means 3 and its formula will be A3B3. Will it be A3B3 or will it be AB? Why? Because for ionic compounds you do not write molecular formula, because there is nothing called molecule can exist in ionic compounds. It's the empirical formula which you write down. Right? So this is the first question and a small iteration of it. Let's just move down to the next question. So this question was the question number 30, assignment 3. Assessment 3, and this next question which is from assessment 4, question number 23. Should I erase? So the next question is the question number 23 from assessment 4. I'm just quickly reading out the solution, question, and then we'll quickly write down the data and interpret it. The question says that in a unit cell, atoms A are present at all corners of the lattice. So I have a unit cell, and in that unit cell there are A atoms which are present at all corners. Right. The second part is that atoms B are present at alternate faces and all edge centers. B is present at alternate faces and all edge centers. Right? Atom C are present at face centers left from B and one at each body diagonal. Atom C are present at rest of the face centers and one at each body diagonal at a distance of 1/4 of the body diagonal from the corner. One at each body diagonal at a distance of 1/4 of body diagonal from the corner. Right? So total fraction of voids occupied are. So the question is, what is the total fraction of voids. Total fraction of voids occupied. Okay, so anyways, there's some problem in the question. Okay, I'll talk about it. Okay, so anyways, so let's just first start deducing the kind of unit cell you're generating. First of all, there's some problem in this question. I'll explain one by one. First of all, this question should have contained the unit cell you're talking about, because it has not been mentioned whether it's a cubic unit cell or is a hexagonal unit cell, is a tetrahedral unit cell. So we are assuming on our own that it's a cubic unit cell, though it's not mentioned. Ideally, it should have been. So let's assume that it's a cubic unit cell. Right. So on assuming the cubic unit cell, because the corner, so like I mean, in hexagonal also they're like corners, their face centers, their edge centers, and everything's there, and their octahedral and tetrahedral voids are there, right? Now, so on the cubic unit cell, if I just talk about the position of these particles, let's just try and understand where all they are. So the A atoms are present at all the corners. This is pretty simple, right? Let's understand what's talk about B. So B is present at alternate faces, which means, for example, if I have a cubic unit cell, so in that cubic unit cell, 6 faces are present. Alternate faces means 3 will be filled, right? And 3 will be filled in such a way that if, for example, this face is filled, so the one of the or 2 of the adjacent faces will not be filled, and then so on. So 3 cases will be filled. So this will be 3. They are like 8, right? We'll talk about their contribution. All edge centers, which means all the 12 edges. At the center of all the 12 edges, B atoms are present, right? For C, rest of the face center, which means on the other 3 faces, C is present, and on 3 faces, B is present, right? And will be filled alternately. Like for example, one will have B, another will have C, and so on, right? And also, it is 1 at each body diagonal at a distance of 1/4 of the body diagonal from the corner. What is this? Can anyone tell me what is this? What is the position it is talking about? Is it some specific position we're talking about, or is it some random position? कोई फर्क नहीं पड़ता ये कुछ. Is it some special position? It has some name. Okay. Now, so what is this position? Let's first understand this. If I talk about a cubic unit cell, in that cubic unit cell, for example, if that cubic unit cell is forming face-centered cubic, so it will have octahedral and tetrahedral void. The body-centered cubic and simple cubic does not have octahedral and tetrahedral void. Are we clear on this, right? Now, so what is the position of tetrahedral void in a FCC lattice? Like I just asked few minutes back, what is the position of octahedral voids in FCC? Similarly, I would also be curious to know what is the position of tetrahedral voids in FCC. Any clue about it? कहाँ पे होते हैं? कितने tetrahedral voids होते हैं? How much tetrahedral voids are there? 2 into Na. So basically, if the rank of FCC is 4, so number of tetrahedral voids will be 8. So there should be 8 tetrahedral voids present in the FCC lattice, right? So what is the position of this tetrahedral void? How do you form a tetrahedral void? How do you, okay, so what is a tetrahedral void? Formed by 4 atoms, but there are a lot of voids which are formed by 4 atoms. So if I place 4 atoms in some random position, they will be forming a void. 3? And how these 3 are placed? Touching each other. So for example, so it means that I have 3 atoms in the base which are touching each other, in which if I join the center of these 3 atoms or molecules or ion or these 3 particles, I'll be forming an equilateral triangle, because this side will be 2r, this side will be 2r, this side will be 2r, right? Now, when I put 3 atoms in this fashion, I'll have a groove, some opening in between. I'll place the 4th atom on top of it, right? Now just imagine the centers of these 4 spheres and forget about the spheres. मतलब just इनके centers को पकड़ लेते हैं and just forget कि spheres are visible here. So if I just take the 3 centers at the base, they will be forming an equilateral triangle. If I take the center at the top, so this will be a point which is connected to these 3 points. It means I'm forming a pyramid kind of shape. If I join this point with these 3, so I'll be forming a pyramid kind of shape formed on a triangle. Now just remember the tetrahedral thing which we talked about in chemical bonding and organic chemistry also. What is a tetrahedron? The trigonal pyramid which has all the 4 triangles as equilateral triangle. All the sides are same sides. Now the atom which you will place over the top of it will also be touching all these 3 atoms. Which means distance between the center of this atom and the other 3 atoms will be 2r, 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 which means all the sides are same. Now, so the geometry you are forming by joining the center of these 4 atoms is a tetrahedron. So that is why the void is called tetrahedral. Similarly, the octahedral case, right? Now, so if I want to identify or locate a tetrahedral void in any lattice, what all I have to do is I have to look for 3 atoms touching each other in a plane and 4th atom touching all 3 of them, right? Now let's imagine, for example, you have with whichsoever room you are, just look at one of the corners and assume this room is a face-centered cubic lattice. So it has atoms at the corners and it has atom at face centers. So now, so in face-centered cubic lattice, if I just consider these face-centered atoms, so now I hope you would know it, like the face-center atoms of each face touches the face-center atoms of adjacent faces. It does not touch the face-center of the opposite face, but it touches the face-center atom of the adjacent faces. Like for example, if I take the face center atom of this face, which is this side of face, it will be touching the face center atom of the other is this face, and this face and this face. It will not be touching the face center atom of this one, because it is like farther from this one. We can calculate and prove it, and I can prove for this one also, but let's not spend time here. But just like remember it as a outcome. In any face-centered lattice, the atoms at one of the face center touches the face center atoms of adjacent faces. So one wall is touched by one ceiling, one roof, and 2 other walls. It's not touched by the opposite wall or the opposite face. So except one face, it touches the all other 4 face centers. Now, so let's just look at one of the corners. Take any corner which you like, right? So on one of the corner, to that corner, 3 faces are joined. If for example in this room itself or here, whichever way you look at, just look at one of the corner. To one corner, 3 faces are joined, 2 walls and 1 ceiling. If you're looking at the upper corner, if you're looking at the lower corner, 1 floor and 2 walls are joined. So at every corner, 3 faces are joined. All these 3 faces has a face center atoms which are touching each other, which means I have 3 atoms touching each other and they are at a diagonal plane. This will be the kind of plane we're talking about, right? Now look at the corner atom. The corner atom touches the face center atoms of its own face, right? So the corner you're looking at, let's imagine an atom there. It will be touching all the 3 atoms of the face centers which are joining this corner. So which means, so the corner atom actually sits on the top of 3 atoms which are face center atoms. So in this plane you form a tetrahedral void. So where exactly you'll find the tetrahedral void? It will be on the body diagonal at a distance of 1/4 of the body diagonal from the corner. So for example, so from every corner, this is the position of tetrahedral void in FCC. So there are how many corners? 8 corners. So from all the 8 corners inside towards the body center, if you move at a distance of √3a/4, which is 1/4 of the body diagonal, you will find the center of a tetrahedral void. The whole tetrahedral void is present inside the unit cell. So it will be contributing whole of its volume. So 8 positions, 8 tetrahedral voids into 1. So it will be 8. So now if you just compare the two, so this is one at each body diagonal at a distance of 1/4 of the body diagonal. So at a distance of 1/4 of the body diagonal from corner, it means it's talking about a tetrahedral void. This is the complex part of the question, right? Now, it says 1 at each boy diagonal. Let's understand this part. What does it mean by 1 at each boy diagonal? How many boy diagonals do we have in a lattice? 4. You take the two corners which are joining. So like so one would be like this, one would be like this. From the other end, one would be this, and one would be this. So there will be 4 boy diagonals. So there is only 1 at each boy diagonal. But in ideal scenario, on each boy diagonal, because from one of the corner, one tetrahedral will be here, from another corner, one of the tetrahedral will be here. So in FCC, if all the tetrahedral voids are filled, so you will find 2 tetrahedral voids per boy diagonal. But it says there is only 1 at each boy diagonal, which means only 4 tetrahedral voids are filled. So I can reprocess the same information and say alternate tetrahedral voids, or no, maybe not be alternate, because alternate will have its own specific meaning. Let's not get into that. I can say half of the tetrahedral void. Got it? So now we know the position of each atoms, right? So let's just quickly figure out their rank and positions. Should I erase this? So A is present at corner, B 3 face centers, and all edge centers, which means 12 edge centers. C 3 face centers and 4 tetrahedral voids. Okay, so before we move forward, let's just also quickly look at this thing also. What is present at the edge center in case of FCC lattice? Octahedral voids. So it's talking about octahedral voids at edge centers. But since at edge center the whole particle does not contribute whole of its volume, it contributes only 1/4 of it, so there will be 3 octahedral voids filled, right? So now this question is pretty simple from this point onwards. So what exactly I have is an FCC lattice which is formed by atoms A, B and C. So I have a FCC lattice which is not ideal FCC, it's a pseudo FCC or FCC like lattice. Why it's pseudo? Because not all the particles are same which are forming the FCC. So A are at the corner, B is at face center, 3 face centers, C is present at other 3 face centers. So B and C are forming the face centers and A is forming the corner. So this clan is forming the FCC lattice. Done? Now, there are octahedral voids and tetrahedral voids filled by the same 3 atoms, or not by A but the 2 atoms. So B is present at the octahedral voids, it's present at 12 edge center. Each edge center contains an octahedral void but contributes only 1/4 of its volume. So it means 3 octahedral voids are filled by whom? B. Right? If I talk about tetrahedral voids, so there are 4 tetrahedral voids filled, they contribute whole of their volume, which means 4 tetrahedral voids are filled by C. Right? You got it? Now, so the other problem with the language of the question is it asks for total fraction of voids occupied are. When I say total fraction of voids occupied, it can also link to those voids which are not really tetrahedral and octahedral but still are voids. I mean, there may be a void space which may not be a category of tetrahedral and octahedral, but in interpretation of the question language, what exactly it means to ask or it tries to ask you is that, for example, there are 10 voids which were available, which you could fill. You could fill only 6. It means you could fill only 60% of the void, or 0.6 as a fraction of the voids are filled, which means 40% of the voids are not filled. So as I know, octahedral voids are in totality 4 and tetrahedral voids are 8. So 4 plus 8, 12. How many of them are filled? 7. So this is the voids, this is the fraction of void which is filled. What is the fraction of void which is not filled? 5 by 12. So what you have all done is that this is the total number of voids, this is the number of voids which are filled. So the whole problem in the question was to identify the position of these particles and which void they are present. To know this, the whole idea of solving this question, or to the learning which you can draw from this question, is that what is the position of octahedral and tetrahedral voids in FCC lattice. Though you should also know the position of tetrahedral and octahedral voids in hexagonal primitive unit cell, but it has not been asked so far, so you can probably skip that. But for FCC, it's been asked multiple times, because in a lot of practical cases which you study, like for example, the zinc blend structure. In zinc blend structure, what happens? The sulfide ions form the FCC lattice, and zinc ions occupy the alternate tetrahedral voids, right? The diamond structure. The diamond structure can also be considered as the carbon atoms are forming the FCC lattice, one set of carbon atoms, and another set of carbon atoms are occupying alternate tetrahedral voids. So which can only be understood if you could understand the position of tetrahedral void. Correct? Right? So I think this is it. You can just calculate and see the answer yourself. So let's just move on to the starting the next chapter, which is solutions. Shall I raise the whole part? The next chapter is solutions or liquid solutions. So in this chapter, we'll be dealing with primarily vapor pressure of the solution, and some properties around it which are called colligative properties, which we'll be discussing tomorrow. So today we'll be focusing primarily on the vapor pressure part of it. So before we move forward, let's just quickly understand what vapor pressure is. We'll spend some time here, because if you'll understand this concept, you'll understand a lot of other things around it. So what do you understand by vapor pressure? Pressure exerted by vapors? As simple as that, right? So it should be, yeah, it is, but there is some condition attached to it. To understand, let's understand what exactly happens, and you'll understand other dimensions of it. So I have a liquid and it has a open surface above. For example, this top is closed in the cylinder. So I have a cylinder, for example, a water bottle which is half filled. There's some space which is empty in this container. So this is an empty space which may contain air, may not contain air, or maybe may contain some other gases. Doesn't really matter to me, because I'm now focused on this liquid. So what really happens in this liquid is that the whole liquid can be divided into two parts. The one part is formed by those molecules which are present on the surface. How do we define the surface? The molecules which are forming the boundary. So they are exposed to us, right, or exposed to their outer world. All those molecules which we cannot see, which are like actually inside the boundary, are called bulk. So the other is called surface, right? Great. Now, the particles present at bulk and the particles present at the surface experience different level of intermolecular forces of attraction, because the particle at bulk will be surrounded by multiple other particles. The particle at surface will be surrounded by limited number of particles in the half hemispherical part. In the upper hemispherical part, it will not be surrounded by any other particle. Now, how does it impact? It impacts in one way, that is called surface tension. I think we have talked about it in the gaseous state. So, but there is another way in which it impacts is the case of vapor pressure, where what really happens is this particle has a different energy than the other particles. Now, because of which what really happens is, if this particle, because in liquid also the particles are in constant motion, they collide with each other just like gases. The difference is their kinetic energies are much lower than the gaseous particles. Their the speeds and their interactions in comparison to gases are different. So what really happens? For example, one of the molecule somehow achieves or somehow gains sufficient kinetic energy which can help it overcome the intermolecular force of attraction around it and escape the whole system and come out in vapor phase. Because, for example, there is a molecule which is in vapor phase. Now, what is the property of this molecule? This molecule has almost zero intermolecular force of attraction with the other molecules, and it has very high kinetic energy, right? Now, in liquid, what really happens? The same molecule, the moment it goes into the liquid state, it becomes part of the society. It has bonds and relations with the people around it, so like other molecules around it. So it has decent amount of intermolecular force of attraction, so which does not let it to go out of the community or out of the society, right? Now, if and at the same time this molecule has low kinetic energy, which does not let it escape the whole system. If, for example, one of the molecule is highly motivated and want to see the outside world, will always run away from the village or society or town. Right? You have seen in like a lot in Hindi movies or like a lot of other movies that Mumbai jana hai, I want to be a hero, right? So this is a move out, right? So similarly, there are other particles which will also try and escape. The one point which must be noted here is that all this escape from liquid to vapor is happening from surface only. This phenomena which is happening in simple words can be called as evaporation. Right? Now these particles which are on high kinetic energy state are colliding with the walls of container, colliding with each other, and at the same time with the surface of the liquid. Right? These community members or these molecules which are in liquid state right now are jealous of these molecules because they are enjoying. Now if they come back and hit them, they'll not let them go. So because what will happen, the molecule, this molecule in chemistry simple words, if it will strike this surface, they may lose some kinetic energy and give it to the other molecule which it is like colliding to, and because of the closeness, it will like the intermolecular force of attraction will increase and it will become part of the liquid state molecule. The process called condensation. We have studied about both of them. So initially what really happens, so when I have a liquid AB, the evaporation, so it goes to vapor state from the surface, the process is evaporation. The vapors, since they hit the walls of the container, hit each other and hit the liquid surface, has tendency to lose some energy and condense. So initially rate of evaporation will be high, rate of condensation will be low because there are no molecules to condense, right? Gradually the rate of evaporation will not be that high, it will decrease, and rate of condensation will increase, and at some point in time the two rates will be equal. So when rate of evaporation is equal to rate of condensation, this thing will attain an equilibrium. When this thing will attain an equilibrium, the number of particles of vapor will be constant, it will not be changing, which for example it means when the equilibrium has been established between evaporation and condensation, and let's assume there are 100 molecules present in the vapor phase and hell lot of molecules present in the liquid state, then these 100 molecules will not change, because if for example 4 will go to the vapor state, the other 4 will come down to the liquid state in the same time period. That is what the meaning of the equilibrium, right? So in this state, number of vapor molecules will be constant. If this number will be constant, then in this duration, under the other condition of volume and temperature, these particles will be applying a constant pressure. So at equilibrium, pressure applied by AB vapors is called vapor pressure. So what is vapor pressure of a liquid? Vapor pressure of a liquid is nothing but the pressure applied by vapors of a liquid on the walls of the container and surface of the liquid when equilibrium between evaporation and condensation is established, or simply at equilibrium. We know what kind of equilibrium we're talking about. So I have two containers. This is a theoretical question we're going to discuss. So I have two containers. Both of them are closed. Both contain same liquid, identical condition. The only condition which is different is the shape of the container, right? So I have a different shape container here. I have different shape container here. Now, and rest everything is same. The temperature, the amount of liquid, the type of liquid taken, everything is there. Like everything is same. The question is, we know that it'll form vapors here. It'll form vapors here. So since the liquid is same, just want to know which container will have higher vapor pressure, right? It seems like that, and it should be. But you know that, now you can catch this is bad. So it seems like that because of the larger surface area, more molecule can go to the vapor phase, and can definitely create more number of molecules in vapor phase, which will be exerting more pressure. A simple logic goes this way, right? But it does not. It's not the case. It will not be higher here. It will not be higher here. In fact, it will be same in both the case. So vapor pressure will be same vapor pressure in both the containers. So what I can deduce is that vapor pressure does not depend upon the surface area of the liquid. So the question is how this surface area A is not affecting the vapor pressure, question 1, which is very important question to discuss. Second is that, but the surface area is different. It should affect in some other way. So let's see in which way it might be impacting, but might not be impacting the final equation, right? Let's just quickly understand that. If the surface area will be large, the rate of evaporation probably will be large, or maybe there'll be more number of molecules going to the vapor phase quickly. But they'll be forming the equilibrium or establishing the equilibrium also quickly, which means the position of equilibrium attained in both the cases will be quite same in some other way, such that this equation will be true. Now, how this equation is impacting this case, let's just quickly understand that. Should I just quickly erase it? I don't have space. Now, for this equation, if I write Kp, equilibrium constant, right, Kp, it will be partial pressure of AB vapor at equilibrium. And we also know that this is nothing but vapor pressure, right? If I just quickly trace it back to the equilibrium constant, this is correlated to Kc, this is correlated to Qc, right? As we studied in chemical equilibrium, Kc is a constant which is fixed for a reaction. It can only change if you change the reaction itself or you change the temperature. These are the only two conditions on which an equilibrium constant will change. Otherwise, what really changes most of the time is reaction quotient, which is Qc. So, which means that the vapor pressure, not really vapor pressure, which means that pressure exerted by AB vapors will be changing. It will try to become equal to the value Kp. The moment it becomes equal to the Kp, the equilibrium will be established, right? So the value of vapor pressure, since vapor pressure is defined only at equilibrium, so the vapor pressure depends only on the value of Kp. For any liquid, the vapor pressure can change if you change the Kp. And since Kp depends upon temperature and reaction, so vapor pressure depends only on temperature and reaction. For any liquid to form vapor, the reaction will be in general like this. It's normally a phase change reaction where a liquid is converting to vapors. So it means that reaction is fixed. It's just the liquid which is changing. So I can say that it depends upon the liquid. So for same liquid, the vapor pressure can change only in one condition, which is temperature. It will not be changing by surface area, amount of liquid. Similarly, I can create a question like, there is one jar which is filled with small amount of liquid. There's another jar which is filled with large amount of liquid. So what will be the vapor pressure in the two cases? It will be same if they contain the same liquid and they are at the same temperature. So it can only change with these two conditions, so which is temperature and liquid. Let's just quickly understand how it changes with temperature, how it changes with liquid. And we'll also understand a term called boiling point. Should I just quickly erase this part? This one as well? लिख लिया? Factors affecting vapor pressure. So as I said, one is liquid, another is temperature. I'm taking liquid first because let's just quickly finish it. So how it depends upon liquid. So can you compare the vapor pressure of 2 or 3 liquids just subjectively? For example, at room temperature, let's suppose I have 2 liquids, one is water and another is octane, petrol. So this is water and this is petrol. How many of you heard that if you just let the petrol tank open, the petrol will go away or it will evaporate completely? If you leave it overnight, you will not find petrol in the petrol tank. Have you heard that? It really happens because you just after coming from office, so sometimes the guy goes to the petrol pump and ask him to just fill it, and this does not close the lid tightly, and it keeps the lid open or maybe partly open, and in morning it finds the amount of petrol to be lesser than but it doesn't really happen with the water. It happens with water, but it takes more time. So in simple terms, I can in layman terms, I can say that this is more volatile than water. How? So basically, so one who is more volatile has more tendency to form vapors. The one who is less volatile has less tendency to form vapors. Now, on what parameter this tendency to form vapor or volatility depends? What is the parameter? How can I compare? Interparticle force of attraction. So the liquid in which intermolecular force of attraction is stronger, the molecules will not be easily be able to go to the vapor phase from the liquid surface, because they would require high amount of kinetic energy to overcome the attractions around, right? So they will be less volatile in nature. It has hydrogen bonding, it has weak van der Waals force of attraction or dispersion forces or London forces. It's a non-polar molecule. So this has weaker intermolecular force of attraction, it has a stronger intermolecular force of attraction. So if one H2O molecule wants to go into the vapor phase, it needs high amount of kinetic energy to overcome the attractions around, and thereby it will be less volatile, it will be more volatile. Those liquids which are more volatile will tend to form more vapors under identical conditions in comparison to other liquids and will be exerting more vapor pressure. So can I say that while comparing the nature of liquid, I can compare that their volatility and which is related to this is a subjective relation. It's not objective, as in the sense that if volatility will be doubled, the vapor pressure will be doubled. If intermolecular force of attraction has gone 3 times down, so it will increase 3 times. No, it's not the case, right? So it's a subjective relation which I've just written here. So what it really means that the liquids having weaker intermolecular force of attraction will be more volatile and thereby will exert high vapor pressure. The weakers with stronger intermolecular force of attraction will be less volatile and will have less vapor pressure. So that's how we can compare various liquids. Like for example, we have studied this in organic. I have 3 compounds. One is N-pentane, another is isopentane, and third is, for example, neopentane. So which will exert highest vapor pressure amongst 3? Which will exert the maximum vapor pressure amongst 3? Neopentane. Why neopentane? So this is the typical case of branch chain isomers of pentane. This is a like non-branched. This is a single branch. There is a double branch. So as the branching increases, surface area decreases, and thereby intermolecular force of attraction decreases. Interparticle force of attraction first depends upon the molar mass, and once their molar masses are same, which is the case here, you start comparing their surface area. So the one which has higher surface area has stronger intermolecular force of attraction in comparison to one has lower surface area. So this has the lowest surface area because of branching, it's taking this shape of a sphere, and thereby it will have lowest intermolecular force of attraction, highest volatility, and thereby highest vapor pressure. Got it? So let's just quickly move on to the next factor. Should I erase this? The second factor is temperature. If I look at this concept theoretically, so theoretically on increasing the temperature, whether, what do you think? Should the vapor pressure increase or should it not increase? Or should it increase? It will change definitely with change in temperature. That's what we have figured out. But will it increase or decrease? Why? Evaporation was taking place earlier as well. So what will change now? Right. So when you will increase the temperature, there are more molecules which are eligible to go into the vapor phase, because in general the kinetic energy values of molecules will increase because kinetic energy of particles is a function of temperature. So if you increase the temperature, the kinetic energy of particles will increase, and there will be more molecules which are eligible to go to the vapor phase, which means more molecule can go to the vapor phase. So possibly the vapor pressure should increase. Now, is there some mathematical relation also? Yes, there is. Do you remember this formula? A log of equilibrium constant 2 by equilibrium constant of first case is equal to delta H upon 2.303 R 1 upon T1 minus 1 upon T2. What is it? What is this formula? Any idea about this formula? No? This is a simple mathematical relation between equilibrium constant of a reaction measured at 2 different temperatures. So we say that any reaction, equilibrium constant of any reaction changes with temperature. So how mathematically it changes? This is a simple equation for that, right? This is the equilibrium constant at temperature T1. This is the equilibrium constant at temperature T2. Now the equilibrium constant will increase or decrease. It depends upon the sign of delta H, whether it's endothermic reaction or it's a exothermic reaction. For endothermic reaction, equilibrium constants increases with increase in temperature. Now, let's just quickly relate this case to the case we were talking about, that we have this equilibrium. Right? The Kp of this equilibrium is called vapor pressure of AB liquid, right? So I can rewrite this equation for this case. So Kp at temperature T1, Kp at temperature T2, right? Since Kp is also equal to vapor pressure, I can replace this equation as log of vapor pressure at temperature T2 divided by vapor pressure at temperature T1 is equal to delta H upon 2.303 R 1 upon T1 minus 1 upon T2. All evaporation processes are endothermic in nature, right? If they're endothermic in nature, so the vapor pressure will be increases with increase in temperature. Mathematically also you can see, and the graph will be sort of exponent kind of graph. We'll just quickly draw, like you can write down the equation. The equation is also called Closius-Clapeyron equation. Done? So let's just quickly move to the graph of this case. So the graph will go like this. So increasing temperature, vapor pressure will increase. Correct? So this is the vapor pressure and the factors affecting it for any liquid, right? So herein we were talking about the pure liquid. What if I dissolve something in that liquid? Like for example, I make it a solution. So I can dissolve some solid substance which dissolves in the liquid but cannot form vapor of its own, right? But may affect the vapor formation or vapor pressure of the liquid itself. Another case is that I dissolved some liquid into this my own original liquid, and it is also affecting the vapor pressure of the original liquid. But in this case, the liquid dissolved now can also form vapors. So we'll be now dealing with the vapor pressure of solution. In this case, in this subtopic, we'll be discussing two cases where one is a solution of a volatile, or you can say it as how it's termed usually, non-volatile solute in volatile solvent. Right, the moment you see this example, imagine NaCl dissolved in water. That's the best case you can imagine, right? Or maybe sugar dissolved in water. So you have some solid substance. It may not be solid, but usually it's a solid, because solids are, very few solids are actually volatile. Almost all liquids are volatile. Gases are anyways, like the vapor phase. So it's certainly be the case of solids dissolved in liquid, right? So when we're talking about a solution of a non-volatile solute in volatile solvent, so the most common case you'll get is a case where you have a liquid wherein, for example, the B is the solvent, which is a liquid, and A is, for example, a solute. This may be solid, but now dissolved in liquid, so it doesn't really matter whether it was a solid or not. But the important information about the two is that this is volatile and this is non-volatile, as I can see from here. So when I'll mix the two homogeneously, so the two will spread or mix completely. So they will also be present on the surface. Now on the surface, along with B molecules, I'll also have A molecules. So now the question is whether the presence of A will affect the vapor formation of B or not, or in simple words, whether it will be affecting the vapor pressure of B or not. So we want to compare when this B was pure, this was the vapor pressure. When I've dissolved some amount of A, the vapor pressure has decreased or increased or not changed, right? If it has decreased or increased, it means it has changed. Then what is the amount which has changed on dissolving in relation with the amount of A dissolved, right? So if I just quickly look at the scenario here, what we found experimentally is that on dissolving a non-volatile solute in volatile solvent, the vapor pressure of the liquid decreases. So if I consider two standard terms which we use very frequently, P naught and PS, P naught is the vapor pressure of pure liquid. Here your liquid is B, and PS is vapor pressure of solution. So which means what all you are doing is that you had a container, you had only B, you measured the vapor pressure here, right? This will be P naught, right? And the same temperature, you opened the container, you dissolved some NaCl into it, or maybe some non-volatile solute into it, and then you measured the vapor pressure, it will be PS. The vapor pressure in both the cases is only and only because of vapors of B, because A cannot form vapors. But since A is present at the launching site or the surface, will definitely be affecting the vapor pressure of B, right? So there are two aspects to it, why exactly A affects the vapor pressure of this liquid B. So the one is that it decreases the number of solvent molecules per unit surface area, which means it has decreased the concentration or density of B present on the surface, so which will impact the rate of evaporation and thereby will impact the vapor pressure, right? This is one way. Second way is that, for example, the B wants to go to the vapor phase. Initially there were only B particles which were around and were attracting this B particle to not go away into the vapor phase. Now instead of just B, along with B there is A is also present, and there may be a case that this A is attracting this B very strongly, much strongly than B. So B will get pissed because B will say, my own molecules are not attracting me that strongly, and you're not letting me go. So because of which this will decrease, right? This all stuff was studied by a guy called Raoult. So he derived a law called Raoult's law, right? In this whole scenario, what he wanted that the derivation which he is trying to form, the mathematical equation or formula he wanted to form, it should not be dependent on nature of substance. For example, because if I'm talking about the second factor, that A is attracting B strongly, that is why B is not easily forming the vapors, and that is what decreasing the vapor pressure of solution. If I take this factor into the consideration, then there will be a problem, because every time I change the A and B, every time that dependence will vary, right? Because it will purely depend upon that who all you have mixed, right? Now, to remove that, Raoult said that I am defining an equation for ideal solution. For him, in this case, the ideal solution is infinitely dilute solution. Because as per him, in infinitely dilute solution, the interparticle interactions becomes almost negligible, because the concentration is so low that you cannot really feel whether A is present or not, right? For example, if I give you HCl dilute solution to drink, you will not drink, or maybe HCl concentrated solution to drink, you will not drink. But for example, if I try a prank, I'll give you pure water with a very small drop of HCl solution, which was anyways very, very dilute. So you may drink it and it will not affect you. Because the concentration of HCl is so very low, it will not at all affect you, but you have had HCl solution, which means that presence of the other solute is not affecting the behavior of the solvent. So that's how it's taken care of. So the Raoult law, or the equation we're going to define, is defined only for ideal solutions, and in this case, ideal solutions are defined as infinitely dilute solution. This thing should be remembered. It's one of the concepts on which one can ask you questions and can twist around. Let's just quickly move to the equation thing, how it impacts. Can you quickly erase these? Let's just understand the factors on which the rate of evaporation and condensation depends. So rate of evaporation depends upon the number of solvent molecules per unit surface area. Right? So when this can also be in other way can also be related to mole fraction of solvent. Right? The rate of condensation is proportional to vapor pressure. Because how the particles are condensing? By colliding with the walls of the container or with the surface of the liquid and losing out their kinetic energy, right, and getting condensed there. So higher the vapor pressure, higher will be the chances of their getting condensed, right? So if I just relate the two, I can say that at equilibrium what really has happened is that rate of evaporation became equal to rate of condensation. In this scenario, what I'm trying to do is I'm just removing the proportionality and putting up a constant here. So I'm just taking this and this, I'm just moving ahead of it. So it is K into mole fraction of solvent. Is it okay? Are you getting it? Great. The rate of condensation is proportional to vapor pressure, and this vapor pressure is Ps. Right, and I have taken a proportionality constant here also. Got it? Now, if I just take this in this fashion, that Ps is equal to K dash upon K, so K upon K dash into mole fraction of solvent. So I generate this kind of formula. So what I need to do is I just need to figure out that what this constant of proportionality is. So this can be defined very easily. Let's take this is done for a solution. Let's take this case to a ideal case, sorry, not ideal case, I would say the pure liquid case, where the mole fraction of the solvent is 1. So if mole fraction of solvent is 1, in this it means that the liquid is pure, there is no solute dissolved in it. In this situation, what is the vapor pressure? It will become equal to P naught. Then in that situation, this P naught will be equal to K upon K dash into 1, which means K upon K dash is equal to P naught. So I can substitute P naught here and I'll generate the formula. Can you quickly remove the upper part here? So Ps is equal to P naught into mole fraction of solvent. This relation is also called Raoult's law. Correct? What should be remembered here is that usually whenever we specify the concentration of any solution, we specify the concentration in terms of the solute, not in terms of the solvent. But herein, as you can see, the mole fraction is required for the solvent, not for the solute. So there might be a case where, in fact, that could be the very common case, where the mole fraction given to you will be that of solute, but what you would require is that of solvent. For example, if I just create a question here. Now, so in this question, for example, I have a glucose aqueous solution, which means the solvent is water and the solute is glucose, which is a non-volatile solute, and water is a volatile solvent. The P naught or vapor pressure of water or vapor pressure of water is also called aqueous tension. So aqueous tension of water is, for example, 300 millimeter of mercury at temperature T. This is for pure. So what will be the vapor pressure of solution? This is asked if mole fraction of glucose is 0.4. So what will be the final result? Will it be 300 into 0.4 or will it be 300 into 0.6? Why 0.6? Because you need the mole fraction of the solvent, which is water, not glucose. So this is a pretty simple thing which you should remember. Should I just quickly erase it? Okay. Another part of it is that the other case. Let's just quickly move to the other case. The other case is solution of a volatile solute in volatile solvent. So I have a volatile solute and it is dissolved in volatile solvent. For example, you can imagine two liquids mixed with each other, for example, methanol and water. Right? So I have two liquids which are mixed with each other, maybe toluene and benzene, or for example, chloroethane and bromoethane, for example. So they are mixed with each other. So they're two liquids of very same kind. They have similar kind of intermolecular force of attraction, will mix homogeneously. In this case, both the liquids are volatile. Now here, I can say solute to anyone, I can say solvent to anyone, depending upon their amount, the composition I have taken. So for example, I have this mixture here of A and B, where A and B, for example, A is a solute again, and B is a solvent again. So I have a mixture of A and B here, and they are forming vapors. Right? In this mixture, the liquid mixture, this is the solution in liquid phase, and this is in vapor phase. Right? Now, so in liquid phase, let's just take Xi A or maybe Xa and Xb as the mole fractions of A and B in this phase. Right? Now, if A is present as a solute here, it will be restricting the vapors of B to go into the vapor phase just because it has occupied the surface, right? Similarly, B is also restricting the A particles to go into the vapor phase, so which means that A is trying to reduce the vapor pressure of B and B is trying to reduce the vapor pressure of A. Let's see how the two impact each other. P naught A is the vapor pressure of pure A. P naught B is the vapor pressure of pure B. Right? Now let's just apply this equation only to the solvent first. Okay? So in solvent, the vapor pressure of the solvent, let's assume that A is not forming the vapors, then in that case it will be P naught B into mole fraction of the solvent itself. Since the two liquids are mixed, in which the solute is the one which is in the lesser quantity and the solvent is the one which is in the higher quantity, but if I just reverse the two, the A will become the solvent and B will become the solute, right? And I can take any composition of the two liquids, so which means that I can do the same stuff for A, that is vapor pressure of A is also being reduced by B, and how it's been reduced by B, as per the mole fraction. So this means that in this scenario, A and B both will be forming the vapors. For example, A is blue and B is black, so both of them are forming the vapors, A is exerting vapor pressure PA here and B is exerting vapor pressure PB here. Now, in this above mixture of vapors, you have two vapors or two gases which are mixed homogeneously, because all gases mix homogeneously. I can apply Dalton's law of partial pressure. So the total pressure exerted here will be sum of partial pressures of each vapor, or I can say the sum of vapor pressure of the each liquid A and B. Right? So using this, I can just put these equations here and I can modify this relation. So the P total will turn out to be P naught A xi A plus P naught B or since I also know that the sum of mole fractions of all the component is 1. So I can deduce this equation only in one of the mole fractions. For example, I deduce this equation in the form of B. So what I have to do is I have to just like substitute A. So P total is equal to P naught A into 1 minus xi B plus P naught B. Now, so this P total will turn out to be P naught and so this xi B can be taken there or maybe here. So P naught B minus P naught A into xi B plus P naught A. So let's just solve a problem quickly. Should I quickly erase it? So it's a very simple problem. For example, there is a methanol and ethanol mixture. You have in this methanol and ethanol mixture, the total vapor pressure can be represented by 120 into mole fraction of methanol plus 140. So what is the value of limit So this is what you have to find out. So there is an expression which is PA upon xi A, right? Or maybe so this A is actually methanol and this is also methanol. So this is the expression you have to find out. So if you look at this equation, this was very similar to the equation which we derived just now, right? Just like, I mean, before this, we derived an equation for the total vapor pressure, which was what? PA xi A plus PB xi B, but we represented it in the form of one of the mole fractions. So there were certain numbers here, and there were certain stuff here. So what it will be, let's just check. If I define this equation, this P total in the form of vapor pressure of methanol, I'm taking M for methanol, and vapor pressure of ethanol, right? So it can be written as P naught into P naught of methanol, which is vapor pressure of pure liquid methanol, into mole fraction of methanol, plus this thing. With this is just something which we wrote. Now as you can see, this equation is written only in the form of mole fraction of methanol. So I have to remove this one. So how can I remove it? 1 minus mole fraction of methanol. So it will turn out to be P naught of methanol, 1 minus this, so minus P naught of ethanol into mole fraction of methanol plus P naught of ethanol. So if I compare this equation with this one, I can see the value of P naught of ethanol is 140, and the value of P naught of methanol minus P naught of ethanol, it is 120. Since this value is 140, it will be 120 plus 140, it will be 260. So which means that P naught of methanol turns out to be 260. Is it okay here? Have you got it? Great. Now, what does this complex expression means? This seems like very complex, but it's very easy. It says that what is the value of this expression when the value of mole fraction of methanol tends to 1? So how do you solve it? Like, I mean, you put it 1 and you solve it like in the closed limit of this value. The moment it will be going close to 1, this solution will become almost pure A. In this case, this vapor pressure of methanol will be almost that of pure. So this will be 1, this will be P naught. So the value or outcome of this expression is nothing but P naught of methanol. So this is what was asked, and this is what you have already derived. Its value is 260 millimeter of mercury. Got it? Clear? So can you solve questions of this kind easily? Great, awesome. Now, let's solve one more question. Should I just quickly erase it? Right. So now you have a volatile solute mixed in volatile solvent. So you have A and B mixed with each other. So here A and B are mixed in liquid state. They are mixed in vapor phase as well. Right. Now the mole fraction of A and B is XA and or you can take it simply XA. Forget about xi. It's XA and XB. Right. And you also know the vapor pressure of pure A and pure B. Right. For example, this value is 600 millimeter of mercury, and this is, for example, 300 millimeter of mercury. And this is, for example, 0.4. Right. This is not given. Now, when the two liquids will be forming vapor, so you'll have a mixture of A and B up here. Right. In this mixture of vapors of A and B, the composition of A and B, which means the mole fractions of A and B, may not be same as that of liquid phase. Let's assume they are different, which will be the usual case. So the mole fraction of A and B in vapor phase is something we are not sure of that what its value will be. And this is something which we have to find out. So this is something you have to calculate. So did you get the question, or should I just quickly explain it again? So you have two volatile liquids, one volatile solvent, one volatile solute. They're mixed with each other. They formed vapors. They formed an equilibrium. You have vapors of A as well as B here. The mole fraction of A and B in liquid phase is driven by XA and XB. The values of XA is given, XB is not given. The vapor pressure of pure A and pure B is also given in millimeter of mercury. You have to find out the composition of A and B in vapor phase, which means the mole fractions of A and B in vapor phase, which are designated as YA and YB. Shall we discuss? Done? Okay. This is pretty obvious. If this is 0.4, this will be 0.6. That's not a challenge. The main challenge is to what this YA and YB can relate to, right? Here I'm dealing with a mixture of gases. If I just go back to the chapter called States of Matter, and if you just remember, there was a law which was dealing with the mixture of gases, and that was Dalton's law of partial pressure. It said two things. One is that the total pressure exerted by a gaseous mixture is sum of partial pressures exerted by each gas, algebraic sum of it, right? I mean, if there are vapors of A and B, so total pressure will be PA plus BB, which we used just recently. It also says second thing, that which is that the contribution of each gas towards the total pressure will be related to its mole fraction. Remember it? So now if PA is the vapor pressure of A here in this solution, it is also the partial pressure of A vapors in this vapor mixture, because I'm looking at it from this perspective now. So it should be equal to mole fraction of A in the vapor phase into total pressure of this vapor mixture. This is something which we have used in Dalton's law, right? Similarly, I can do it for B. It will be this. Now I also know that the pressure of this A vapors is related to total pressure using the Dalton's law. It's also related to mole fraction of A in liquid phase using the Raoult's law. So PA is equal to mole fraction of A into P naught A. This has come from the Raoult's law, and this has come from the Dalton's law. Now equate the two, if I equate the two, I'll get two equations. If I equate these two equations, I'll get Ya into P total is equal to Xa into P naught A. Are we okay with it? I've just equated the two equations, so I'll get this, right? In this case, again, equate the two equations, you'll get Yb into P total is equal to Xb into P naught T. Got it? If I divide these two equations, so what will I get is Ya upon Yb, this P total will cancel, is equal to Xa upon Xb into P naught A upon P naught B. Now this is a pretty good relation which serves like to solve this question very easily, because you know the value of Xa and Xb, you know the value of P naught A and P naught B, so you'll be able to get the ratio of Ya and Yb. At the same time, Ya and Yb are mole fractions of a mixture. All mole fraction of a mixture sum up to 1. So I also know the value, I also know one more relation, so I can quickly calculate the value of these two mole fractions. Can you just quickly calculate the answer? It should turn out to be 2 by 3, 2, 4 by 3. It should be 4 by 7 and 3 by 7. Right? Great. A second problem around it. You can just quickly write down. Should I erase this one? No. You have this formula with you in your notebook, right? The last one, right? So we'll be using it in the second question. So the second part of the same question is a different situation now. You have identical container kept at identical conditions, not initially, but later on, yes. What you have done is, this is an empty container. You have collected all the vapors here present in the first container and have taken them to second container, condensed them using high pressure or maybe low temperature. So now you have a mixture of A and B here, right? And then took it back to the original normal condition. Like, I mean, initially what I've done is I've taken these vapors, condensed them, created them, made them become a liquid, and then left the container at or normal condition, which is the identical to this one. For example, it is at 50 degrees Celsius, it is also at 50 degrees Celsius, it's at 1 atm, it's 1 atm, whatever. So there's like identical conditions here. Now, so when the identical conditions are achieved or normal conditions are achieved, A will be forming vapors here, and B will also be forming vapors here. In this mixture, let's assume the vapor pressure of A and B is Ya dash and Yb dash, and mole fractions of A and B, and mole fraction of A and B in this liquid phase is, let be, Xa dash and Xb dash. So you need to calculate this value using the same values. 3 by 11? 3 by 11 and 8 by 11. How did you calculate? Hmm. Hmm. Great. So basically what we can do is like, I mean, if I've taken all the vapors here from this case and I've condensed them here, so the number of moles of A and number of moles of A here will be same. Similarly, the number of moles of B and B here will be same, which means the mole fractions will also be same. That is, the XA dash will be equal to YA and XB dash will be equal to YB. The two will be same. Though when you keep the same liquid at normal conditions, some of the molecules will go to the vapor phase, and this may change the the mole fractions here. But usually, whenever your liquid forms an equilibrium with the vapor phase, very few molecules actually go to the vapor phase. I mean, the amount of molecules go to the vapor phase. So it may change, but that change is so like small that you can neglect it and you can keep it as same. So you just need to calculate this YA dash and YB dash. So you can apply the same formula for the second container, which was YA dash upon YB dash is equal to XA dash upon XB dash into P naught A upon P naught B. The same formula but for the second container, in which I know that XA dash and XB dash are equal to YA and YB, and I've calculated the value of YA and YB. I can put it here, but I'll not do that. I'll just like go it, take it more forward. I'm just putting the value of Y and YB and directly the value of Y and YB here, which is the XA and XB upon P naught A upon P naught B into P naught A upon P naught B. Right? I mean, did you get how this thing came here? So XA and XB, so XA dash and XB dash is equal to YA upon YB, and we had a formula for Y and YB which was equal to XA upon XB into P naught A upon P naught B. So this formula can be reduced to YA dash upon YB dash is equal to XA upon XB into P naught A upon P naught B whole square. Now what is the advantage of deriving this formula is that if I repeat the process to third container, the same logic will apply again and similar kind of expression will be formed. And if I apply this process to 100 containers, and if I ask you what is the mole fraction of A and B in vapor phase in 100th container, how will you calculate? You will not do it 100 times, but you can form a generic formula using it. And what will be the formula? The formula will be mole fraction of A and B in vapor phase of nth container. So this n belongs to nth container I'm talking about, is equal to XA and XB 1. This belongs to first container you were dealing with into P naught A upon P naught B to the power n. So if you have to calculate for the 100 container, you can quickly calculate it. Can we just raise the other part? If I want to draw the graph for various composition and the vapor pressure allocated to them, so I can do it using this equation that PA is equal to P naught A XA. So if I draw the graph of PA with respect to mole fraction of A, so as I can see, it's a straight line passing through the origin y is equal to mx, but it will be a line segment because the value of mole fraction cannot go above 1. And when mole fraction is 1, this value will be equal to P naught A, right? Similarly, I have it for B. PB is equal to P naught B mole fraction of B. So when mole fraction of B is 1, the vapor pressure will be P naught B. Right? Now, what if I want to draw the two graphs on the same, graph platform, wherein I just want to coincide the horizontal axis. I cannot coincide the axis just like that, because the moment the value of mole fraction is of A is 1, the value of mole fraction of B is 0, because the two are related through a linear equation that XA plus XB is equal to 1. So it will, when it will increase, it will decrease. So when it will be 1, it will be 0. When it will be 1, it will be 0. So which means that these two graphs will not coincide just like that. The two graphs will coincide like, if I have this graph, I take it up and flip it and put it here, right? Which means so I've taken XA 0 to 1, so this value will be P naught A. I've taken a reverse graph XB 0 to XB 1, so it's coming from this direction. So this is for the PB. So this graph is for PB and this graph is for PA. Right? Now if I join these two values, the graph obtained here, it's a straight line, and it actually represents the total vapor pressure. All of them are straight line. It may not look like, but it is. Pardon my drawing skills. So this is total pressure, this is for PA, this is for PB, right? Now, what to be understood here is that if I have a composition here, for example, this mole fraction of A is 0.3 and mole fraction of B is 0.7. So how this graph can help us is this graph can help us that if I form a solution of A and B, any composition, right? So can I quickly know right from the graph without going into the laboratory that what is the vapor pressure exerted by A, what is the vapor pressure exerted by B, and what is the total pressure exerted here? Yes, I can see it from this graph. At this composition, if I just create a marking here, this point will give me the vapor pressure of A at this composition. This point will give me the vapor pressure of B at this composition. This point will give me the vapor pressure, total vapor pressure of the mixture at this composition. So for this composition, it will be different. For this composition, it will be different. Like for example, if I see a reverse composition where XA is, for example, 0.8 and XB is 0.2. Now this is the mixture which is enriched with A. This is the mixture which is enriched with B. Herein I can see the vapor pressure of B is higher than that of A, but in this case you can see the vapor pressure of B, A is higher than that of B. Right? So we'll understand more about this graph and the cases of ideal and non-ideal solutions, because in this case as well we have to define the ideal solution. We'll also understand what really happens if the solution is not ideal, and what really happens to this graph and what can actually change, and in which cases, all cases it happens. So we'll talk about that in tomorrow. Tomorrow we'll also be studying about the colligative properties. So just spend some time today in revising this concept which you have studied today, and also some time maybe from NCRT only, just to understand a quick read about the colligative properties and the non-ideal and ideal solutions. Okay, thank you. Thanks for the day.
So last time we finished matrices and determinant, right? So now we are going into one of the most important, not only as far as your IIT JEE is concerned, but also uh, your life, your career, when you will be going beyond after class 12th. So this branch of mathematics, that is called calculus, right? So we are stepping into one of the most important branch of mathematics called calculus, right? Now, you see a tremendous progress in science and technology, right? You see that. And the major force behind this progress, this tremendous progress of science and technology, has a larger part to play with mathematics. So mathematics has a larger contribution to this development. And the branch of mathematics which plays a very important role is calculus, right? So there are basically two branches of calculus. One is integral calculus and the other one is differential calculus, right? Now, if you see the area of physics, geography, geology, economics, biology, financial mathematics, and in a very late recent time, it has penetrated the areas of social sciences as well. So calculus is going inside everything for solving their problems, right? Let's say, at what speed should a rocket be launched so that it never comes back to Earth? Calculus has to give the answer. Suppose a stain of bacteria, it's growing proportionate to its amount, and let's say it doubles itself in 2 hours. At 4 hours, what should be their concentration? Let's say a certain force is exerted on a spring to stretch it by 1 feet, let's say. Then let's say if I have to stretch that spring by 2 feet, how much work is required? So I have chosen different type of problems from different fields, and they all have the answer in the technical aspect of calculus. But if you see calculus, it has not only to do with a technical tool, but it is a collection of fascinating and exciting ideas which has attracted thinking men from centuries. Okay. Now the calculus, it has mostly to do with speed, area, volume, the rate of growth, the tangent line. They talk about these ideas, right? And when you see these ideas has contributed to the development of all the sciences which we have already talked. Okay. So you see the calculus is going beyond all these ideas. It is more to do, it's not only to do with the qualitative, the quantitative aspect, the technical tool, but it is basically becoming an idea which is attracting people, right? But one of the most unifying power of calculus, that it formulate the idea into one. It sees something and it formulates into a one idea. It has a power of formulating it. Now, if you see historical evolution of calculus, it dates back 2000 years back. It was Archimedes who was the first fellow who was working on calculus. It was basically the Greeks. And they were trying to find the area of circle. They were trying to find the area of parabola. They were trying to find the area of curves. And Archimedes was the one who was successful in finding the area of circle, finding the area of parabola. So what he was using while finding the area was the theory of exhaustion. You know the theory of exhaustion? You must be knowing, but you don't know that was theory of exhaustion. Because when you were trying to find the area of a circle, what they were doing, they were trying to inscribe it a polygon inside and then outside. And then they were trying to approximate the area. And the moment they were increasing the polygons, because it was easier to find the area of polygons, right? So they knew how to find the area of polygons, but they don't know how to find the area of circle. So they used the theory of exhaustion. They were creating a polygons and number of sides they were increasing, and they were getting nearer and nearer. And as long as they were doing it, as long as the whole curve exhaust. That was the theory of principle of exhaustion, and they were trying to find the area. But after Archimedes, for 1800 years, there was no progress in calculus. Now, this progress in calculus started in 16th century, when we were able to find decimals. We were able to use plus and minus sign for the very first time in 16th century. We transited from Roman numericals to Hindu Arabic numericals, which we are using, right? And then there were Italian mathematicians like Tartaglia, Cardellano, Ferrari. These people were able to solve, as we already talked about them when we were studying complex numbers, right? So these were the people who solved cubic equations, quintic equations, and they were able to give us the, so that was the thing which primed again this calculation part of this. And then it laid the foundation of calculus, and then Newton and Leibniz took it further, right? So this was basically, this is the historical evolution of calculus. Now, if you observe calculus, calculus originates from 3 words. These 3 words have the same origin: calculus, calculate, and calcium. These 3 words have the same origin, and that origin is calculus, and that word means pebble. What does it mean? Long a time ago, pebbles were used for counting, right? So from here, this thing developed. Now, calculus has 2 major branches: integral calculus and differential calculus. It has to do with the area, and it has to do with the steepness of a tangent, right? Now you must be thinking that differential calculus must have come before integral calculus, because in your textbooks you always study differentiation and then you study anti-differentiation, because it's easy to differentiate, it's easy to create, it's easy to destroy, it's difficult to create, right? So integration is much to do with a creating thing. So it's a difficult thing, it's a difficult task. And destruction is obviously it's an easy task. So आपको लगता होगा कि differential calculus came into being for the earlier than integral calculus, but that's a wrong concept, because as you know, Archimedes laid the backbone and he was trying to find the area. So it was integral calculus which penetrated first, and then differential calculus, right? So we study differential calculus, so we will be making sense why we are studying differential calculus first. But you must understand that in historical evolution, it was integral calculus which came first. Now, if you observe this, you must be thinking, why am I talking so much about calculus? Because calculus is only about functions and all, but it's not like this. You must understand what you are doing. Then only you will be able to appreciate calculus. Otherwise, it will become a bland thing, which is right now for you people. Now, let's say this is a curve C. Let's say this is a curve C. Now, you want to assign some number to this area. So who is going to help you? Integral calculus. And suppose you want to assign a number to the steepness of this line, this tangent line. So who will help you? Differential calculus. So this is the basic background of calculus. So you understand what is calculus now, why it is important, how it came into being, right? And how it has changed everything. The science and technology, whatever the advancement you're seeing, they are lying on the backbone of calculus, right? Now, when I talk about calculus, I try to see calculus as some story. If you observe, when you see a movie or story or novel, you see a book or novel, what do you see? You see, first of all, the characters. right? You see the characters, you have protagonist, you have antagonist, you have main lead, you have supporting lead, you have uh, good guy, you have bad guy, you have everything, right? And then the story builds into the interaction between them, those characters, right? There can be a love story, there can be a mystery, there can be a revenge story, right? There can be a suspense. So basically, it's an interaction between the characters, and the story is being led there. Similarly, when you observe calculus, it is also a story in which the characters are your functions. Those functions are your characters and their interactions. What is happening at that point? What is the relation between these two? How they are behaving when they are doing this way, right? So basically, a story is being knitted on the characters of functions. Now, function is a difficult concept, how it has come to your life. So whenever we introduce any difficult concept in us, what we do go to solve that concept in an intuitive way. We try to find what does it mean, right? So we'll try to discover what function is actually, what does it mean, right? And also, when you see the basic foundation of calculus is also lying on the limits. Limits is something which talks about on the nearby zone, nearby some point. It's not talking about what is happening at that point. He's talking about what is happening near to the point, in the neighborhood of this point. And when we will study limits, and from the basic of limits, we'll be trying to calculate limits, various limits. We'll try to create a mathematical tool as a limits, and then everything, the continuity, the differentiability, will develop from the concept of limit. So limit is very strong concept. So limits you have to be very focused. You have to understand why we are doing it, right? So without wasting much time, we'll start our story from the mathematical point of view. So it was simply a basic introduction of calculus, why it is important, how it is being structured. So that was a forest view of the calculus. Now we'll start tree by tree, each tree, and then we'll start our understanding each tree, and then we'll understand the whole. So first, before we go into thing, we must understand what are sets. Any idea what are sets? You must have studied in class 11th. What are sets? You don't know what are sets? What is a set? Set is a bag. Set is a bag where you put objects, which you call elements. When you don't have element, it's an empty bag. You denote it by phi. When all the elements are present, you say it is a universal bag. It contains everything. That was the basic definition of sets. You know empty sets, you know universal set, right? Then we have already studied permutation combination. We understood the concept of and we understood the concept of or. Or means union. Or means addition. Or means addition, or means union. Means addition and union are exactly the same thing. And means intersection, and means multiplication. So multiplication and intersection are exactly the same thing, right? Now you must have understand, we have already discussed Venn diagram. Venn diagram, when we were studying permutation combination, we have already dealt Venn diagram. So we have already handled what is A union B. We have already handled what is A intersecting B. We have already handled what is A complement, what is B complement, what is A minus B, what is B minus A, what is A union B ka complement, right? So everything. And whenever, if you forget the properties, you know how to handle the distributive and associative laws of plus and minus. So exactly you can handle union and intersection. So union would become your plus and intersection would become your. So I hope there is no issue in sets. The basic of sets, right? You know how to represent a set, a roster form and a set builder form. You understood it, no need to go into that. You also understand how to denote A, B, close bracket, semi-closed, open bracket. You know it? Okay. So no need to talk about that also. Now going further, you know how to find subsets, number of subsets. We have already done in permutation combination. If you have 5 elements in a set, how many subsets are possible? 2 raised to the power 5. Why? Because you are going to create subsets out of those 5 elements, right? So you are going to ask each element, are you in or out? So each element has 2 options, and you are going to ask every element. So the AND condition. So 2 into 2 into 2 into 2 gives you 2 to the power 5. Exactly. So that is the basic concept of sets. So no issue till in sets, no issue in Venn diagram. Okay. Now going beyond, I'm trying to find a Cartesian product of 2 sets. What is Cartesian system? Have you heard this word Cartesian before? When you were studying coordinate geometry. Cartesian system. Why did we talk about Cartesian that time? Because we were interested in the ordered pair. AB and BA are not same thing in Cartesian system, right? So that's why we talked as Cartesian. So when I say Cartesian product of 2 sets, what does it mean? I have, let's say, okay. Now, when you talk about Cartesian product of 2 sets, let's say this is your set A, and let's say this is your set B. Okay. Now you have, let's say, 3 elements here, A, B, C, and let's say you have 4 elements here, 1, 2, 3, 4. Right. Now, when I say Cartesian product of 2 sets, I'm going to symbolize its A cross B. So it will also be a set, which is a product of these 2 sets. And these 2 sets will give me each element as a ordered pair. So A will be mapped with 1, A will be mapped with 2, A will be mapped with, A will be mapped with. Likewise, B will be mapped with 2, 3, 4, and C will be mapped with 1, 2, 3, 4. So you have a set which has, I'm writing in a roster form, A1, A2, A3, A4, likewise B1, B2, B3, B4, C1, C2, C3, C4, right? This is your roster form, and you have all the elements of this Cartesian product A cross B. Now these, यहाँ पे इसका element था ABC, इसका element था 1, 2, 3, but A cross B का element क्या है? Order pair A1, order pair A2, order pair A3, order pair A4, right? Clear or not clear? Understood? So this collection is called Cartesian product of 2 sets. So it had 3 elements and it had 4 elements. How many elements it has? 12. So you can create a logic that if it has m elements and it has n elements, how many elements will A cross B have? M cross n, right? M into n. Understood? And the order will be important. If I say A cross B, it is A1. If I say B cross A, it would be 1A, 1B, 1C, right? So abscissa and ordinate are important, right? Understood? So this is basically Cartesian product of 2 sets, which is also a set. Which is also a set, a collection of elements. Now, if I ask you, how many subsets can I create out of it? 2 to the power 12 or 2 to the power mn. So these subsets will have an empty set as well, will have a universal set as well, right? So these 2 to the power mn sets are basically my, what do we call this? Relation. We call it relation. Okay, let's say out of this, if I say A1, B2, C4, ये एक set बना दिया मैंने. So this is basically a relation. So ऐसे जितने भी subsets होंगे, how many relations you will have? 2 to the power mn, right? That is called relations. No problem here in a basic definition. When I say empty relation or when I say no relation, it means no relation is also a relation. What is the relation between two? There is no relation. That is the relation. Right? Understood or not understood? तो relation का basic definition clear हुआ? We'll not go very deeply into the relation thing. We'll just understand what is relation. This is a basic definition. And function is a special type of relation. So function is further. Function is a relation, but it has some constant. What are the constants of function? We'll discover intuitively first, and then we'll make it as a definition. Understood? Now, going into this, before going into the function thing, we must know what are relation. So you understand these are all the subsets are called relation. Now, let's say I create A cross A as a Cartesian product. I have built a relation in A. I have built a relation in A. And suppose all the elements of A is like A1 comma A1, A2 comma A2, A3 comma A3. So all the relation, if certain relation has all the thing which is abscissa and ordinate, they are same. So what do we call this type of relation? Symmetric. Reflexive. Right? There are three types, symmetric, reflexive, and transitive. So this is basically, if it is true for all the elements in A, if it is true for all the elements in A, we call it reflexive. Right? And what about symmetric? A1 A2 bhi hai or A2 A1 bhi hai. So this becomes, but this is true for all the elements. अगर एक भी element इसको violate कर रहा है, so it's not a symmetric relation. So this is your reflexive relation, this is your symmetric relation. And now there's a third one, that transitivity, which gives the relation a transitivity. Like let's say if I am better than him and he is better than C, then that obviously makes that I am better than C. Right? Clear or not clear? So that is the theory of transitivity. So if say for every element, let's say it is true A1, A2 and A2, A3. If these two is follows for all the elements, then they must have, this is transitivity. And when these three properties are reflected by any relation, we call it a equivalence relation. So it's a very small topic and not very much concerned with IIT JEE. IIT JEE most have to do with the functions and all, right? So this is the part you know the basic thing. Understood? No problem till here. Now my question is, what does it mean to be a function? When I say function, what does it mean? What does it makes? So whenever I introduce any concept which is basically a difficult concept, we must bring it in a very friendly manner. Let's say I have a cat and it's a very lovely cat and I call him Roxy. Okay, and I want to find the age of my cat. So obviously you must be thinking it's my cat, I must be knowing what the age is. Of course I know. And it is let's say it's 1.3 human years. So what's the age of the cat? 1.3 human years. Now I want to find the age of cat in cat years. So you must be thinking, why cat years? Oh, cat years are different from human years. Of course it is, because cat grows in a different fashion, their growth is different than us. They grow faster than us. Don't you remember the Jungle Book? You remember Jungle Book? The wolf, the Akela and then mother wolf, they got Mowgli as a baby cub. And then then the wolf had baby wolves as well. But when Mowgli was 8 or 9 years old, they were already grown wolves. Right? Why? Because they grow in a faster fashion. Right? Similarly, the cat also grows in a faster fashion. So let's say I have to find my cat who is 1.3 human year old, how much he is old as far as cat is year is concerned. So the basic idea is here is I have a collection of human years and you have a collection of cat years. And for every human year, I will have a certain cat year. Now, let's say I have this collection. I know that when my cat Roxy was 1 human year old, she was 12 cat years, let's say. Okay. Now, when my Roxy was 2 years old, he was 24 years old. Okay. When he was 3, was 28. When he was 4, she was 32. ऐसे करके I got some information. When she was 9, she was 52. Right? These are the information. So like you have some human years, and then you have certain mapped cat years. Right? So it's not the idea how. Here we are not interested how human years is becoming cat years. But what here is important, that for every human year you have a, so this human years becomes your input and this cat years becomes your output, and you call this thing as domain and this thing as range. You call it range. Understood? The output, the collection of output is range. You understand there is a difference between codomain and range. When we were talking about the Cartesian product of two sets, he had A cross B. The set A was your domain and set B was your codomain. And it is different from range. Range will be either equal to codomain or less than codomain. Right? We'll try to formulate that also. So what's the idea here to notice? I don't know how I am getting this cat here. There is something happening here in my box and I'm getting my result. Right? This is how I'm trying to find. But the question was asked, my cat Roxy is 1.3 human year. So how old she is when we are talking about in a cat years term. तो क्या करते हैं सबसे पहले, we'll start plotting them. We'll start plotting them. तो जब आप plot करोगे cat और human को, cat year और human year को, right? So I'm going to put my human year here. So 1 के साथ you will plot 12, right? 2 के साथ you will plot 24, then 28, 32, 36. Will we go this way? So it will be something like. Now, you'll try to say that okay, f of 1.3. जैसे आपसे मैंने पूछा 1.3 क्या है, तो आपने क्या किया, इसको उसी मशीन में डाल दिया निकालने के लिए कि आपका ह्यूमन ईयर कैट ईयर क्या होगा, राइट? तो आपने यहाँ पे सिंपल पहले आपने देखा कि आपका जो फंक्शन है, अगर आपका x 2 से कम है तो इट इज फॉलोइंग 12x ग्राफ, है ना? एंड जैसे वो से बड़ा हो रहा है, इट इज बिकमिंग अ, व्हाट इज दिस पॉइंट 2, and what is this point 3, क्या स्लोप चल रहा है? 4 का स्लोप चल रहा है ना? 4 का स्लोप चल रहा है, तो इट इज 4x प्लस क्या होगा? Right? This is the story. This is your function. Now you have to find the Roxy in a cat here. So you are going to put 1.3 here. सो 1.3 जब आप यहाँ पुट करोगे तो किस में लाई करेगा, फिर आपको इसमें फीड करोगे, एंड 12 into 1.3 that becomes your 15.6 cat years. So you understood what is the idea here? That you have some inputs, you have some outputs, and every input must have one output. Every input must have one output. So this is the idea which I wanted to talk. Understood? Now similarly, if you see this function, let's say you have a collection, you were in a lab and you have collected your data in degrees Celsius, and then you have to send it to your friend and he wants everything in Fahrenheit. So again, you will be putting every input into that machine which will give you. So we are right now not interested in what is happening inside the machine, but what is the idea here is that every machine is having some input and throwing a output, right? So this is basically, you can consider the function as a machine box F, right? And you are putting some inputs, you throw it in, and something comes out. So this area, this collection, this set is called your domain, and this set is called range, right? यहाँ तक कोई प्रॉब्लम नहीं है, तो आपके लिए लाइफ में फंक्शन कैसे आ रहा है आपको समझ में आ रहा है, राइट? अंडरस्टूड और नॉट अंडरस्टूड? क्लियर? तो एक बहुत ही स्ट्रॉन्ग कॉन्सेप्ट आपके फंक्शन के साथ आया, दैट इज डोमेन एंड रेंज. Domain is basically collection of inputs and range is basically collection of outputs. Now, let's say, so basically एक function का एक strong idea So basically, you have this story. Right. Now my question is, when can I say, so basically now your story, your life, the characters is this function. Now my question is, when can I say two functions are same? When can I say? So you know function has something to do with inputs and something to do with outputs. You put something in, it will throw something out, right? इतना basic आपको पता चल गया. So और उसके एक बहुत ही important, the very important characteristic is the domain and the range, right? Now my question is, when can I say my two functions, they are same? When range are equal. Domain and range both are equal. Okay, let's say if I say fx is x square plus 2x plus 1 and gx is x plus 1 ka whole square. Are these two functions same? Why? Why they are same? So simple answer, if you put the input, they will give you the same output. For every input, if you put f1, it will become 4. If you put 1 here, it will become again 4. If you put 2 here, it will become 9. If you put 2 here, it will become 9. Right, so your idea become that if two functions can be said equal if they have the same set of inputs and same set of output. My next question is, hx is x square by x and qx is x. Are these two functions same? Why? If I put 5 here, I'll get 5. If I put 5 here, I'll again get 5. At 0, you cannot put here. If you put 0 here, error. Not in domain, right? So the basic idea is, when can we say two functions are same? Understood or not understood? Clear? Now let's say I have to create functions from functions. I have to create 2 functions, 3 functions together. So let's say this is a function f, this is a function g. So you are putting something here, x, you're getting something, fx, and then you're getting something. Right? Likewise, if you are putting g first, f here, you're putting x here, this become gx, and this become, इसे हम क्या कहते हैं? कंपोजिशन फंक्शन, कंपोजिट फंक्शन. इसे आप गॉफ एक्स कहते हैं, इसे आप फॉग एक्स कहते हैं. राइट? ये बात आपको समझ में आता है? फॉग एक्स, गॉफ एक्स. राइट? नाउ व्हाट इज इंपॉर्टेंट हियर is the domain of a composite function. What is the domain of a composite function? सबसे पहले let's say I have to find let's say I have to find fog. ठीक है? And let's say gx is x minus 5 and fx is root x. ठीक है? Now fog हो गया क्या? You put g first and then you put f first and you get fog. So let's say if I put 5 here, I'll get 4 and then root 4 is 2. No problem. है ना? If I put 1 here, I'll get 0, I'll get 0, no problem. If I put 0 here, I'll get problem, error. है ना? So what is the idea here? The idea here is the domain of fog should be domain of gx first and gx must be in the domain of understood or not understood? So how can you calculate the domain of fog? Simply, you must know the domain of G and then you must know the range of G, and those range of G needs to have an intersection with the domain of F. Right? थोड़ा सा complicated लग रहा है ना? So it's a very difficult, it's a difficult idea, but when you are doing it, when you think in a very mathematical fashion, you will be able to understand what am I talking. Understood? So how to find mathematically? Simple, the set concept. Domain of gx and gx must be in the domain of fx, in दोनों का intersection. Understood? The intersection set would be your domain of fog. And when I ask you to find the domain of GOF, domain of fx, and fx must be in the domain of, and मतलब क्या हुआ? Intersection, right or not right? Understood? We'll be doing the questions, बस आज मैं थोड़ा सा तुम्हें intuitive ideas दे रहा हूँ कि क्या हो रहा है life में. ठीक है? We'll go into it, much into it. So I'll just talk about some important functions. We have already created a library of functions, right? What are there in our library? We have trigonometric functions, we have logarithmic functions, We have exponential functions, we have polynomial functions, we have rational functions, we have linear functions, we have complex functions. We don't have to study complex function. Yes, complex function is a very fascinating thing. It's very good, but we don't have to study complex function. We have to study only the real valued functions. Okay, that is why we are getting an error here. Otherwise, if it would have been a complex function, it would have produced iota. Understood? So we are not interested right now in complex function. We are not interested in the complex analysis. Maybe in higher studies, when you will be pursuing mathematics, you will be studying the complex analysis, which is a very beautiful branch again, which talks more about beauty, symmetry, and then the tremendous development in science and technology, right? So basically, we have already talked about complex numbers, right? And now we have already talked about calculus. So you must understand why we are studying mathematics. That is the idea. Mathematics is nothing like a Greek and Latin language. It's something to do with your own life. Okay. Now, where were we? So you know how to find the domain. But the idea is why we are pushing this idea. We are pushing this idea so that we develop an idea of invertibility. The idea of inverse function. Basically, inverse function is also a composite function. How? If these two functions are inverse to each other, so whatever fellow I put here, they will create something. I don't know what they will do it here, but they will surely do the same thing out, right? So before going into that invertibility concept and the composite function concept, I wanted to talk about a little basics regarding the function definition and all. So basically in function, what we have understood right now is that it's a special type of relation, right? What type of relation? That every input, that each element of domain must have an output. The first condition, every element of the domain must have an output and one output, only one output. Let's say if you have a calculator, if you're pressing 2 plus 3, you're getting 5. And at the same time, you're getting 6. It means your calculator is not functioning properly. And if you're pressing plus button and it's not adding, again it means there are some inputs जिसका आप output नहीं निकाल पा रहे हो. Again, your calculator is not functioning. So function is something like each element, each input must have some output, and that output should be 1. है ना? एक input का दो output नहीं हो सकता है, right? The second thing, that every element should have output. These are the only two constants of function, which is a special kind of relation, right? Understood or not understood? Now, अब आपने ये देखा होगा कि एक एलिमेंट का एक आउटपुट ये तो फिक्स हो रखा है, राइट? सो बेसिकली आपके पास 4 रिलेशन बन सकते थे. एक रिलेशन बन सकता था 1-1, एक रिलेशन बन सकता था 1 many, एक रिलेशन बन सकता था many 1, और एक रिलेशन बन सकता था many many. ये 4 रिलेशंस आपके बन सकते थे, है ना? ये चारों बनेंगे तब भी क्या बनेगा? रिलेशन. अब फंक्शन क्या है? इट्स अ स्पेशल रिलेशन जिसमें दिस डजंट कम इन आवर डेफिनेशन. व्हाई? वन input should have one output. So this left side is talking about inputs, and this right side is talking about, so these two gets out. They are relation, but they are not function. So you have broadly 2 kind of functions, 1-1 and many 1. What is 1-1 function? That you have 1x, 1y, 1x, 1y, one input, one output, one input, one output, like the example of cat ear and human ear. है ना? 1.3 पे 2 चीज तो नहीं आ गया था ना? अरे 29 साल भी हो गया, 40 साल भी हो गया, ऐसा तो नहीं हुआ था, राइट? सो एक के साथ एक के साथ एक, दैट इज 1-1 रिलेशन. और हर ह्यूमन ईयर्स के साथ आपका एक कैट ईयर था, है ना? सो देयर वाज नॉट अ सिंगल इनपुट जिसका आउटपुट नहीं था. Then only it can be categorized as a function. Now the second thing is many 1. Many one means दो different inputs का same output आ रहा है. Let's say 2 plus 3, 4 plus 1, 3 plus 2, 6 minus 1, 7 minus 2, everything is giving me 5. Fine, my calculator is working. Understood? So the function, you can have a different inputs giving your same output. So many x, 1 y. Many x, 1 y. So basically you have two types of function, one function and many one function. So there is no problem in understanding one function and many one function, right? Understood? Now there is also one thing which talks about codomain and range. Which talks about codomain and range. When you are creating relation, when you are creating Cartesian product of two sets, you know from where codomain is coming. है ना? The second one of a Cartesian product gives you the collection of ordinates. That gives you your codomain. And then you put inputs and you get your outputs. So that is also a collection. Now that collection of output can either be equal to the codomain or smaller as a subset of codomain, because it has to be mapped to the right side. It has to be mapped to the right side. Let's say if you have to find fx is equal to x square and you have created x cross y where x is the element of real number and y is the element of real number. So you have this collection of real numbers, all positive, negative and zeros, and you have all real values here. But when you put a function of x square here, so आप जितने भी values डाल दो, negative डालो, positive डालो, zero डालो, everything will map to the upper portion, positive or zero, right? So there are elements in codomain which will not be associated with the inputs, right? So this will become your into function. So when your range and output, they are equal, we call it onto function, and when the range is a subset of codomain, it means a into function. Understood? Now why are we talking about one and onto part just before the invertibility? Because we have already defined our basic thing regarding the function, that you can go from left to right only if one input has one output and each input must have an output. ये दो constant है. And when I say inverse, if I go from left to right or right to left, in both way, my function should not be abused. Then only we can say the function is inverted, right? So in the case of many one, you can go from left to right. Different values of inputs are giving you the same output. But when you go from output to input, that is the inverse part. Now your output becomes your domain and input becomes your. So when you are coming from right to left, what is happening? You have one many relation which abuses your function definition. So it means that function is not invertible. Understood? So what is the first condition for a function to be invertible? It has to be 1, 1. Right? Now the second thing, let's say you have two type of functions, onto or into. Onto means all the elements of codomain has been exhausted. All the elements has been exhausted. And let's say the function is 1, 1. Obviously the first condition is that the function has to be 1, 1, then only you can go from right to left and left to right. So you went there, it's fine, there's no issue because that the function is already defined. And when you are coming from left to right, you have all the elements, you have all the inputs for which you are getting your output when it is onto. When it is into, what's happening? Some of the elements do not have the outputs. So the second condition, second important condition is that the function should be onto. So when a function is 1, 1 and onto, when a function is 1, 1 and onto, 1, 1 has another name interjective, onto has another name surjective. When the function is 1, 1 and onto, interjective and surjective, then the function is called bijective. which means invertible. Understand? So this is the idea of invertibility. है ना? Understood or not understood? Now, if you observe the whole idea, but sir, we understand what is happening here, but what is the mathematical aspect? How to calculate it? So, first of all, we'll be doing certain exercise and finding out the domains. We have already done certain time. So, we'll be trying to know how to find the domain. Then we'll try to know how to find the range. And then we have already done in class 11 some portions in finding the domain and the range in the, right? And when we'll be plotting the graphs, we'll also understand what is it. And then when the mathematical aspect of finding how to function is 1, 1, when we'll be understanding differentiation, we'll understand that also. Because we know strictly increasing or strictly decreasing would be a 1, 1. Otherwise, the second alternative approach of proving something like 1, 1 function, what we have to plug, I have to plug on the left hand side fx1, on the right hand side I have to plug fx2. And then I have to show that this equation has only one solution, that is x1 is equal to x2. If that solution is not there, it means that function is not 1, 1. Understood? This, and how to prove something, some function as onto or into? You have to write you have to express x in y. You have to express your x in y, and then you have to show that for all the y, you have certain x. You have to show that for all y, you have certain x. And once you have proved that your function is 1, 1 as well as onto, it means your function is bijective, it means your function is invertible, so you get a green signal of going for finding the inverse. Now what you have to do, if you have passed through these two prerequisites, that okay, you have proved that the function is 1, 1, and you have proved that the function is onto, what you have to do now, you simply have to write y, x in terms of y, and then x to be replaced by a function f of x, and y to be replaced by x, and that is your new function. F inverse x is equal to x, whatever the thing is. So these are the mathematical way how to get your inverse function, how to get your domain, how to get your range, how to prove that a function is 1, 1, how to prove that the function is into, how to prove that the function is inverse, right? Clear? यहाँ तक कोई problem है? नहीं? So let's do certain practical tasks regarding invertibility. Let's say I'll just give you a practical example. Let's say you are filling a pool. एक pool आप fill कर रहे हो, right? You're filling a swimming pool. एक hose से आप swimming pool को fill कर रहे हो, और आपको एक function पता है कि आपका जो volume of water है, after certain time of आप जो hose कर रहे हो 1 घंटे 2 घंटे 3 घंटे के लिए, जब आप उसको खोल के रखते हो, तो that is given by this quantity 700 t plus 200. मान लो आपने 1 घंटे के लिए खोला, तो आपने कितने fill up कर दिए? 900 gallons, let's say 900 liters. Okay. So at 1 hour, how many water is coming in the pool? 900 liters, right? This is the thing which is telling you this, right? Now, अब question है कि what does the inverse of this function means? What does? तो मैं इस क्वेश्चन को इस तरीके से पूछ सकता हूं कि आपको ये पता चल गया VT का मतलब क्या हुआ? How much liter of water is filled in T hours? ये मतलब हुआ ना VT का? और मैं ये कह रहा हूं T in terms of V का मतलब क्या हुआ? Huh? How much time it takes? It takes to fill V liter of water. Understood? So basically these two are your inverse. Understand the idea? ये हो गया आपका कि जो certain time पे ये दे रहा है और ये हो गया आपका जो. So what would be this? If you plot it, this one, if you plot it, कैसा होगा इसका ग्राफ? At t is equal to 0, it will start with 200. यहाँ कहीं पे है ना? And then it will be a straight line. This would be your y is equal to x line. Right? ये कैसा होगा? V minus 200 यही होगा ना? Again, it would be something like जब आपका क्या कहोगे तुम इसको? आपने उल्टा कर दिया ना, पहले ये था आपका t और ये था आपका v. आपको ये कैसे मिलेगा जब आप उल्टा कर दोगे, है ना? तो it would be something like this, जो भी है इसके mirror image. My idea to represent right now is that inverse function are mirror image about y is equal to. Now the second idea which I want to throw is that you know function का inverse कब होता है? जब वो 1-1 हो और on 2 हो, basically जब वो bijective हो. But still we are trying, we have always found that square root is the inverse of x square, but x square is not a 1-1 function. We have already know that sin inverse x भी होता है, cos inverse x भी होता है, but sin x and cos x, they are not 1-1. We have already discussed log and exponent, you know that they are 1-1, so fine, we have already found out. But how? And this is also 1-1 because it's a linear function, so this is also a 1-1. So it can easily be created into invertibility. Simple that we know that they are 1-1. And but how to find the inverse of many one function? कैसे करेंगे? जैसे अभी आप लोगों का इनवर्स की क्लास स्टार्ट होगी, इनवर्स ट्रिगो ने आप लोगों ने कर ही लिया होगा. So how you were finding the inverse part? How you were trying to find y is equal to sin inverse x, cos inverse x, tan inverse x? क्या कर रहे थे? आप देख रहे थे कि y is equal to sin x 1-1 कहाँ है? तो आपने ऑब्जर्व किया था -π/2 से π/2, then π/2 से 3π/2, then 3π/2 से 5π/2, right? That was the story of your sin x. And 1-1 इसी पोर्शंस में हो रहा था. तो आपने कहा कि सर ये सारे ब्रांचेस के लिए वी कैन क्रिएट आर 1-1, राइट? फिर उसके बाद आपने देखा जो ओरिजिन के पास है -π/2 से π/2, that turned out to be a principal solution, principal branch. Similarly, for tan x, again -π/2 से π/2 open, turned out to be the principal thing. और किसके लिए हुआ था? cosec. cosec के लिए turned out to be -π/2 से π/2. And that is why आपने देखा कि जो भी -π/2 से π/2 के प्रॉपर्टी सेम से हो रहे थे. When we'll be studying inverse, हम लोग इस पे ज्यादा स्ट्रेस करेंगे, राइट? तो आपने क्या किया बेसिकली, आपने अपने फंक्शन को -π/2 से π/2 में डिफाइन करके सारी चीजों को रिमूव कर दिया, राइट? Then you will have a 1-1 relation. Similarly, for a quadratic equation, let's say you are throwing a stone up. You're throwing a stone up. So basically your definition is height is ut plus half t square. ये होता है ना, ut plus half gt square. Now you see at two different times you are getting the same height, है ना? Then you cut your movement of your stone as one time going up, then you can find the inverse when it is going up, and when it is going down you can find the inverse, right? Clear or not clear? So this is the idea that how to find the inverse of any many one function. Many one function को inverse निकालने के लिए आपको क्या करना होगा? आपको सिंपल उसका एक certain branch कट करना होगा जहाँ पे वो फंक्शन 1-1 है, और फिर उसके बाद आप उसका वो कर सकते हो, राइट? क्लियर? और आपको पता है कि कैसे आपको करना है. You just have to replace it. Clear? So आप लोगों ने वेवी कर्व ये सभी पढ़ा होगा, राइट? वेवी कर्व पढ़ा है ना? यू नो एट what point the function is positive, at what function is negative. वेवी कर्व से आपने डोमेन रेंज भी निकालना सीखा था, राइट? जब आप डोमेन निकाल रहे हो, certain things to be kept in mind while finding the domain. You don't want zero in the denominator, first thing. जब आप डोमेन निकाल रहे हो, you have to be very careful that यहाँ के बंदे को मुझे जीरो नहीं होने देना है. The other thing which you know is स्क्वायर रूट के बंदे के जो अंदर है उसको हम क्या नहीं होने देंगे, नेगेटिव नहीं होने देंगे. इसको हम कभी जीरो या जीरो से छोटा नहीं होने देंगे. और इसको कैसे करके मिक्सअप भी करो तो यू हैव टू फॉलो इट, राइट? उसके बाद इसको हम कभी -1 और 1 के बाहर नहीं जाने देंगे, है ना? ये सब चीजें डोमेन निकालने के टाइम में आपको हेल्प करता है. और रेंज निकालने के लिए क्या करते हो आप? x को y की तरफ करते हो. अगर आप रैशनल फंक्शन बनाते हो तो फिर डिस्क्रिमिनेंट का कॉन्सेप्ट यूज करते हो कि व्हेन x इज द एलिमेंट. किया है ना वो सारे क्वेश्चंस कि नहीं किया है? किया है, गुड. आज हम लोग बस विल टॉक अबाउट इट, जस्ट नेक्स्ट क्लास से हम लोग पे टोटल क्वेश्चंस पे आ जाएंगे. Now, the next idea is let's start collecting some of the important functions, right? आपने greatest integer function की बात की है कभी? क्या होता है greatest integer function? If I say इसको डिनोट करते हैं ऐसे, ग्रेटेस्ट इंटीजर फंक्शन. इसका मतलब क्या होता है? इसका मतलब होता है कि आप x को कहीं पे भी प्लॉट कर दो और इससे लेफ्ट में जो भी नियरेस्ट इंटीजर है वो इसका बंदा है, राइट? सो अगर ये x, इट टर्न आउट टू बी x व्हेन if x इज द एलिमेंट ऑफ इंटीजर, है ना? अदरवाइज क्या हो जाता है? The one who is on the left side, right? Clear? तो इसको प्लॉट करने की कोशिश करते हैं. कैसा होता है इसका ग्राफ? कैसा होता है इसका ग्राफ? जीरो का क्या होगा? ऐसे ही चलेगा ना ये ग्राफ? दिस इज योर ग्रेटेस्ट इंटीजर फंक्शन. इट्स अ वेरी इंपॉर्टेंट फंक्शन, इस पे ध्यान रखना. विल डिस्कस मोर अबाउट इट. हम लोग बेसिकली ये भी सीखेंगे f ऑफ x से f ऑफ ये बनाना, फिर f ऑफ x से f ऑफ ये बनाना. बहुत सारे इसमें जो ट्रांसफॉर्मेशंस हैं हम सीखेंगे. हाउ टू फाइंड द फ्रैक्शनल पार्ट ऑफ fx, हाउ टू फाइंड द f ऑफ फ्रैक्शनल पार्ट x. So you know basically every number can be written as right, and you know है ना, ये सब आइडियाज हैं सब कुछ के. तो इसके क्वेश्चंस हम लोग करेंगे कुछ, राइट? तो ये आपका हो गया ग्रेटेस्ट इंटीजर फंक्शन, है ना? लेट्स से इफ आई आस्क यू टू ड्रॉ दिस, बना लोगे? कैसा होगा बनाओ तो ग्राफ. फिर ये भी बनाओ. दोनों ग्राफ बनाओ. लेट्स ड्रॉ. Will this denote a greatest integer? बनाते दोनों के फ्रैक्शन ग्राफ. देखो मैंने 3 लाइन बनाई है y के. क्या क्या 3 लाइन बनी है? y is equal to 1, y is equal to 0 and y is equal to. मैंने ऐसा क्यों बनाया? क्योंकि मैं इस पूरे फंक्शन पे ग्रेटेस्ट इंटीजर लगा रहा हूँ, राइट? तो जहां जहां पे 1 हो रहा है वो तो मेरा फंक्शन का पार्ट बन गया. ब्लू से भी दिखाता हूँ. आई एम ड्रॉइंग द ग्राफ विथ ब्लू. तो ये तो मुझे पता चल गया कि पाई बाई 2 पे ये होगा. इसको कोई नहीं मूव कर सकता है, राइट? ये दिख रहा है? और -1 पे कोई मूव नहीं कर सकता क्योंकि मुझे पता है इंटीग्रल पार्ट पे वो इंटीजर ही बन जाता है एग्जैक्टली द इक्वल. नाउ यू नो 0 पे फिर से 0 ही रहेगा. देखो जहां जहां इंटरसेक्ट कर रहा है उसको मैं वहीं पे फिक्स कर दे रहा हूं, राइट? दिख रहा है? सी द मैकेनिज्म. जहां जहां पे 0 बन रहा है वहीं पे मैं फिक्स कर दे रहा हूं. नाउ आई नो दिस जोन 0 to 1. 0 to 1 में क्या होता है कहानी? 0 ही रहेगा ना. क्लियर? एंड -1 से 0 में क्या कहानी हो जाएगा? -1. तो इसके लिए इस होल लेके यहां पे आ जाएगा, राइट? एंड देन यहां पे फिर से होल बना देगा एंड दिस विल टेक. फिर यहां से देखो किसी भी फंक्शन का ग्रेटेस्ट इंटीजर पार्ट बनाना कितना आसान हो गया. कोई भी कर्व होता क्या करते तुम? ब्रेक करते, स्लाइस अप करते, राइट? और जहां जहां तुम्हारा कर्व जितने वैल्यूज के लिए उस दोनों पोर्शन में स्टक होता उसके लिए सीधा लाइन खींच देते, जो मैंने किया. अंडरस्टूड और नॉट अंडरस्टूड? समझ में आया? ये ग्राफ समझ में आया ना? यहां पे क्या होगा? लेफ्ट साइड में मैंने बनाया नहीं. अगेन यहां क्या हो रहा था? नीचे हो रहा था ना. ये तो यहां कनेक्टेड रहेगा, फिर यहां पे 0 हो जाएगा, फिर ये ऊपर चला गया था ना, यहां से यहां रहा, फिर यहां पे खुल गया, फिर यहां. क्लियर? सो द ब्लू पोर्शन इज माय रिक्वायर्ड ग्राफ. अंडरस्टूड और नॉट अंडरस्टूड? Now let's say I have to draw sine of greatest integer x. क्या करें? ये तो और आसान हो गया. क्या हो गया? 0 से 1 तक 0 रहेगा तो 0 स्ट्रेट लाइन. 1 पे क्या बन जाएगा? sin 1. और कहां तक रहेगा sin 1? 2 तक, sin 1, फिर sin 2. अच्छा, sin 1 और sin 2 में बड़ा कौन होगा? क्यों या क्यों नहीं? कैसे? तो 2 तो भाई पाई के नज़दीक जा रहा है, ये तो पाई से भी आगे बढ़ गया. यहाँ पे बेवकूफ़ी मत करना, यहाँ पे 1 2 3 रेडियंस हैं, समझ में आ रहा है? तो देख लेना कौन बड़ा है. sin 1 और sin 2 में बड़ा कौन होना चाहिए? देखो 2 वुड बेसिकली बी ग्रेटर देन पाई एंड वुड बी लेसर देन 3 पाई बाई 2. तो बेसिकली नेगेटिव होगा sin 2. sin 2 नेगेटिव होगा, नीचे ही आ जाएगा, समझ रहे हो? और sin 1 ऊपर ही रह जाएगा. sin 1 is something like 57 degree, 57 58 degree, right? That is sin 60, that is sin 60, root 3 by 2 से हल्का सा कम. ठीक है, ये सब बेवकूफ़ी मत करना. sin 1 के ऊपर लिख दिया sin 2, sin 2, sin 3, sin 4, sin 5 ऐसे करके. ठीक है, you should don't worry, वो ज़्यादा इरिटेट नहीं करेंगे, वो जो भी रखेंगे थोड़े से ही वैल्यू पे रखेंगे. ठीक है, they just want to see the basics कि whether you understand it or not. Understood? तो ये जो फंक्शन है ना, तो you understood how to find this if you know the graph of fx. Slice it up, जो भी पोर्शन है उसके हिसाब से वो slant line बनना लगेगा. And you know how to handle this. है ना? इसका मतलब है कि आपको डेसिमल वैल्यूज ऑफ x पे बात ही नहीं करना, सिर्फ इंटीजर वैल्यूज पे बात करना, और वो सारी वैल्यूज उसको दे देनी है 0 से 1. इट वुड बी अ पैरेलल लाइंस टाइप पे चलते रहेंगे. क्लियर और नॉट क्लियर? अंडरस्टूड? देखो sin 0 क्या होगा? 0, और 0 से 1 तक वो रहेगा 0. ये 1 हो गया और ये 2 हो गया. 1 से 2 तक कहानी 1 ही रहेगी, sin 1 ही रहेगा. sin 1 मान लो ये हो गया, which would be close to 0.8685 जो भी है. ठीक है, फिर तुमने यहां से sin 1 ड्रॉ कर दिया ये तक. ठीक है, ड्रॉ कर दिया. sin 2 जो हमने पता चला था कि नेगेटिव है, समवेयर हियर. sin 2 कहाँ होगा? नीचे होगा. और ये कहां तक रहेगा? 3 तक. तो यहां पे आ गया sin 2. अब sin 3 कहां होगा देख लो, वो भी नेगेटिव ही होगा. sin 3 3.14 से छोटा होगा और वो बड़ा ही होगा, sin 2 से पक्का बड़ा ही होगा, है ना? तो कुछ यहाँ पे आ जाएगा sin 3. समझ रहे हो? इस तरीके से आप हैंडल कर लेना. शेयर अप दिस. आज की क्लास ज्यादा हिस्ट्री की लग रही है ना? हाँ, मैथ्स की कम लग रही है आज की क्लास. ऐसा क्यों? Because calculus is something like which needs to be interpreted, which needs to be thought about. Graphs, आप ये सब चीजें जान जाएंगे तो the moment you have a graph, you know the story. It's better to have a picture than to have 1,000 words, right? यही होता है ना? It's better to, a picture is better than 1,000 words. This is the saying, ना? So when you have a graph, you know it. When you don't have a graph, you just find the algebraic properties और एक दो point के बारे में बात करते हो. But when you have a graph, you can talk about any point. ठीक है? Explain the graphs again. Which graph? See, I am trying to draw this graph. So when you are drawing this graph, simply first draw sin x. And then you know that sin x is chopped between 1 and -1. And see, 0 से यहाँ तक ये दोनों चॉप्ड है यहाँ तक. तो जहाँ जहाँ ये इंटीजर पॉइंट को टच कर रहा है वो तो उसको बना दो कि ये पार्ट ऑफ फंक्शन बन गया. वो उसको वहाँ से कोई नहीं मूव कर सकता है. तो हमने उसको यहाँ बना दिया, राइट. और हमने देखा इस पोर्शन तक बंदा 0 से 1 तक की कहानी 0 ही रहेगी. तो हमने इसको ऐसे लाइन करके यहाँ से ओपन कर दिया. एंड देन वी ड्रॉ दिस. यहाँ से बंदा नेगेटिव हो चुका है तो पक्का ये -1 की तरफ अब बढ़ जाएगा क्योंकि वी नो द ग्राफ ऑफ ग्रेटेस्ट इंटीजर x. एंड देन यहाँ पे यही है, ठीक है, यहाँ पे फिर ये हो गया, देन ये यहाँ आया खुला, एंड देन ये, ठीक है, अंडरस्टूड? I hope you understand mod function as well. What is y is equal to mod x? हाँ, क्या होता है y is equal to mod x? Minus x for x less than 0 and plus x for x greater than, यही होता है ना? And you know how to draw the graph? This is your y is equal to x line. And whatever you see below will be reflected up. So this is your y is equal to mod x, right? Clear? No issue here? आप इसको handle कर सकते हो? So now handle this. करा चुका हूँ? तो you know how to handle all the three, है ना? क्या करोगे? y is equal to sin x, mod sin x में क्या करना है? Whatever you see below, up. इसमें it means there is no difference on the left and the right. So whatever you see on the right will exactly be the, है ना, sin mod x, मतलब इसके लिए तो वही रहेगा, the curve, and the same it would be something like this. ये तो होगा, and then right यहाँ पे ये same होगा, symmetrical. Whatever you see on the right, and what about this? It means ये नेगेटिव वैल्यू लेगा ही नहीं, तो ये सारे पोर्शन खत्म हो जाएंगे और ये ऐसा बनेगा, है ना, अंडे अंडे से, और 0 से पाई, फिर पाई से 2 पाई फ्री हो जाएगा, फिर 2 पाई से 3 पाई रहेगा, फिर उसके बाद फ्री हो जाएगा, फिर ऐसे ही बनेगा. क्लियर? अंडरस्टूड? Now, what is a linear function? So see, if क्या कहते हैं, जो हम लोग अभी whatever we are understanding our idea of calculus, we understand that it is talking about all the problems whatever we are seeing in the world right now. Now there is certain type of problem which talks about the constant growth. Something is growing constantly, ठीक है? मान लो जैसे there is this girl Rapunzel. Now she is growing her hair, है ना, यही था स्टोरी ना. So जब 9 months में she grew, let's say 20 meter hair, and let's say 18 months में she grew 30 meters. So 24 months में how much length she will have, है ना? So this is the story of Rapunzel. How to get this one? So you know it is growing at a constant rate, right? 9 is plotted with 20, 18 is plotted with 30. So basically it becomes a equation of line thing where you have 2 points, right? So you can easily tell that in 24 months Rapunzel will have particular length of. So this is basically a constant growth thing. So linear function के idea आपको समझ में आ रहे हैं? No issue till here? Okay. Now other important functions which we talk about is, अच्छा, did we talk about the graph of fractional part? No. Okay. So since you know what is a fractional part, this is your, इसके ग्राफ कैसे बनेंगे? इसका ग्राफ कभी नहीं बनाया? नहीं बनाया? Why? देखो, यही तो है मेरा फ्रैक्शनल पार्ट, है ना? नहीं बनाया है? बनाया है ना? भूल जाते हो क्या तुम लोग? सो दिस इज योर फ्रैक्शनल पार्ट, है ना? इंटीजर वैल्यूज पे क्या हो जाती है कहानी? 0, और उससे पहले क्या रहता है? द सेम नंबर जो फ्रैक्शनल पार्ट का है. सो बेसिकली इज इट अ पीरियोडिक फंक्शन? Yes, it is a periodic function. After trigonometry, this is the only periodic function which you are going to see, right? जिसका period क्या है? 1. Period is the length. Its period is 1. अच्छा, इसका ग्राफ ड्रॉ कर लोगे आप? इसका ग्राफ दोनों का ग्राफ ड्रॉ करो तो. आप लोग तो इंटीग्रल कैलकुलस कर चुके हो ना? तो क्लास बोरिंग सी लग रही होगी कि क्या पढ़ा रहे हैं सर, ये सब तो आता है, बट इज इट समथिंग न्यू टू इट? नई चीजें समझ में आ रही है? इट्स गिविंग यू अ डिफरेंट पर्सपेक्टिव, राइट? In IIT, students are solving the most difficult in the IIT JEE. I find students entering in IIT, they are solving one of the most difficult questions of calculus in their JEE examination, but they don't know anything what is calculus. They are just solving it like a puzzle, like a riddle. They're doing it, okay. If this is there, then I have to differentiate. I have to find the local max. I have to find the local mean. I have to find the point of inflection. I have to find this. I have to find the symmetry. And then they are doing it. And they're finding the answer in the right way. But the idea is they are becoming a mechanical robot, which take a certain inputs and then throws a certain output. But they themselves are not understanding why they are finding particular thing. So calculus has something which needs to be thought rather than something which needs to be mechanicalized. The curly branch, this denotes greatest integer function and this denotes the fractional part. Now the fractional part is basically when you see any number x, it has two things, an integral part and the fractional part. Let's say if I say 7.29, so it can be written as 7 plus 0.29. So this 7 is your greatest integer part and 0.29 is your fractional part. Even if you say 0.39, so the integer it has is 0 and the integer fractional part is 0.39. Even if you talk about minus 1.7, so it can be written as minus 2 plus 0.3. So this minus 2 is your integer part and plus 0.03 is your fractional part. So this fractional part is represented by a curly bracket. Right. Now when we are drawing y is equal to curly bracket sin x, how to go for it? Y is equal to this I have to draw. So it's a very easy thing. Why it is a very easy thing? This is your function. Okay, let's say I'm drawing only the right side. Okay. So this is your function. Y is equal to sin x. And you know from 0 to 1, the integer part what they are getting is 0, 1 and minus 1. Only 3 portions. जहाँ पे fractional part क्या हो जाएगा? 0. तो वो सारे पॉइंट को तो तुम यहाँ खींच के ले आओ. है ना? ऐसा कुछ हो गया? अच्छा, 0 से 1 में क्या रहेगा फ्रैक्शनल पार्ट? एग्जैक्टली सेम. राइट और फिर एग्जैक्टली सेम। यहां पे क्या होगा, यहां पे क्या होगा, यहां पे ये -0.1 हो गया। -0.1 में फ्रैक्शनल पार्ट क्या रहा, 0.9। तो क्या हो रहा है कहानी, यहां पे इसको कुछ ऐसा होना था, समझ में आ रहा है, नहीं समझ में आ रहा है, नहीं समझ में आया, आ गया। यहां से फिर से ये 0, यहां पे इसको 1 होना चाहिए था लेकिन 0 हो गया। लेकिन अब क्या हो रहा है, 0.9 फिर से बढ़ के कहां जा रहा है, 0 की तरफ बढ़ रहा है। एंड देन अगेन क्या होगा, ये अंडरस्टूड। फिर ये कहानी फिर से स्टार्ट हो जाएगी। समझ में आ रहा है कि नहीं आ रहा है, नहीं समझ में आ रहा है, अंडरस्टूड, ओके। पक्का समझ में आया कि नहीं समझ में आया, कितने लोगों को नहीं समझ में आया, आया समझ में, नहीं आया समझ में, बेवकूफ लड़की, इधर देखो, 0 पे 0 और π/2 पे 1, तो 1 पे फिर से 0 आ गया, तो मैंने इसको खींच लिया। लेकिन इससे पहले जो भी होगा 0 से 1 की कहानी होगी सेम होगी ना, और यहां पे भी सेम होगी ना, क्योंकि फ्रैक्शनल पार्ट 0 से 1 तो सेम ही रहता है ना, इट फॉलोज सेम थिंग। आप 0.9 डालोगे 0.9 निकल के आएगा, 0.8 डालोगे 0.8 निकल के आएगा, तो यही फॉलो करेगा ना, इसी पाथ को फॉलो करेगा, इसी पाथ को फॉलो करेगा। नाउ टिल पाई पे भी 0 रह जाएगा। ना यहां पे क्या हो रहा है, यहां पे आने पे क्या हो रहा है कहानी इसकी, -0.01 -0.02, लेकिन फ्रैक्शनल पार्ट तुम माइनस रख सकती हो क्या, नहीं, इट हैज टू बी पॉजिटिव, तो तुम ऊपर ले जाओगे, तो इट विल फॉलो द सेम पाथ। यहां पे आके 0 बनेगा, यहां पे फिर क्या हुआ, फिर से ये 0.9 -0.9 -0.8 जा रहा है, जो कि कन्वर्ट होके क्या बन रहा है, इसी पाथ पे बढ़ेगा, पाथ वोंट चेंज, उसी ग्रोथ पे बढ़ेगा। एंड देन अगेन यहां पे आके 0 हो गया, फिर कर्व फॉलो करेगा, फिर तो साइकिल रिपीट कर जाएगा, राइट, अंडरस्टूड। तो आपको 0 से 2 पाई तक का ऑब्जर्व करना, उसके बाद रिपीट करा दो। क्लियर और नॉट क्लियर। अब साइन ऑफ फ्रैक्शनल पार्ट x, just I'll do this and then we'll discuss one problem from matrices. There was a query, so we'll discuss that query. तो साइन जल्दी से इसका ये बताओ, तो जल्दी से ड्रॉ करो। यही था। So you done with this? बन गया, कैसा होगा, पहले तो साइन x बना लो, बन गया। अच्छा, फ्रैक्शनल पार्ट ऑफ x मतलब यू आर ओनली इंटरेस्टेड इन द फ्रैक्शनल पार्ट। तो ग्राफ 0 से 1 तक कोई प्रॉब्लम नहीं है, सेम प्रोड्यूस करता रहेगा। यहां पे आके साइन π/2 पे क्या हो जाएगा, 0, यहां आ जाएगा, राइट। उसके बाद क्या होगा, 1.1 घटने लगेगा ना, 0.9 पॉइंट ऐसे ही आएगा ना, जैसे फ्रैक्शनल पार्ट क्या हो जाएगा, 1.1 1.2, तो फिर से कहानी स्टार्ट हो गई ना, ऐसा ही हो जाएगा ना, समझ में आ रहा है। जो कहानी 0 से 1 के बीच में होगा वैसा ही कहानी, पूरी ग्राफ को मिटा दो और क्या करो, क्योंकि आपको पता है f of gx में अगर gx आपका पीरियोडिक फंक्शन है तो f of gx भी पीरियोडिक फंक्शन होगा और पीरियड सेम रहेगा, राइट? ये पीरियोडिक फंक्शन हो गया ना, जो भी होगा हमेशा 0 से 1 की वैल्यू देगा ना, 0 से 1 की वैल्यू तक क्या ग्राफ है बस वही देख लो, 0 से 1 के लिए एक वैल्यू है, 1.1 से 2 तक के लिए यही कहानी हो जाएगी ना, सो इट विल स्टार्ट अ रिपीटिंग। तो कोई भी फंक्शन हो, यू जस्ट हैव टू सी 0 से 1 तक ये कहानी क्या है, ये कहानी है, पूरा मिटा दो और फिर क्या करो, समझ में आया कि नहीं समझ में आया? क्लियर? तो फ्रैक्शनल पार्ट ऑफ f ऑफ फ्रैक्शनल पार्ट x के लिए क्या करना है, remove all the graph, just observe what is happening between 0 to 1 and that will be the graph repeated for all the integral. You know the period will be 1. Now coming, we'll continue in the next class the domains and all. I'll just discuss this determinant problem of this matrices. Now if you observe this matrix, I'll just write this matrix here. You're taking it? Okay, please take it there. So if you observe this determinant, what do you observe about this determinant? This matrix, this structure. What do you see? So basically it's a symmetric matrix, right? Now you have to find the determinant. What is the thing which is troubling you? This is troubling you, right? है ना? तो जब आपको symmetric matrix में ऐसी trouble आती है, तो what you do basically, you try to, since it is a symmetric, you try to break the symmetry and get something into, when determinant में आप किसी एक को 0 बना रहा हो, that is the target, right? If you got something as 0, आपका एक रो कॉलम का problem solve हो गया, that's why, and then the calculation becomes very easy. Now what here you have to do, you observe A everywhere. Here you observe B everywhere, and what is troubling here? X. In all the three rows, X is the one which is not letting you do this. है ना? X is the one which is not letting you do this. So what you can do is you can multiply the whole thing, this whole first row, by A. When you multiply the whole thing by A, what you will get? A cube plus AX, right? The same thing, you can multiply the second row by B, you'll get A square B, B cube, BX, and then B square C. And the same thing you can get by multiplying by C. So जब तुम ABC multiply कर रहे हो तो make the balance, you will divide by ABC. ठीक है? Understood? Now you know this is a symmetric matrix. The row and column, if they are interchanged, they will remain same. When you did this, you got something similar here. A cube plus AX, A square B and A square C. No, sorry, AB square and AC square. In all the three fellow, you have A common. Similarly, what you got here? A square B, B cube BX, and then BC square. तो आपको सिमेट्रिकली A भी मिल गया, B भी मिल गया, C भी मिल गया, आपने उसे बाहर निकाला. तो जो ABC बाहर नीचे था वो था कैंसिल आउट हो गया, एंड देन योर मैट्रिक्स हैज बिकम समथिंग लाइक A square plus X, B square, C square. This has become A square, B square plus X, C square, and this has become C square. ये क्या बनेगा? A square, ये B square और ये C square plus X. Understood the idea? Now it's very easy for you to get 0 and X. है ना? मैं करके दिखाऊं? दिखा देता हूं. So whenever you find the symmetric matrix, you can easily break the symmetry by this concept, multiplying with it and then dividing by it. You will get the extraction and then everything will become easier to differentiate. So look here. So this is your A square plus AX, A square B, A square C AB square B cube plus BX plus B square C AC square BC square and C cube plus CX. आपने नीचे क्या कर दिया 1 by now I see A common from this column, I see B common from this column and C from, तो मैं इसके A को हटाने के लिए क्या कर दिया, इसको बना दिया A square plus X, यहाँ से A हटाया, यहाँ से A हटाया, यहाँ क्या लिख दिया A. Similarly I removed this B, I made this B square, I removed this, I removed this, what I made it B, and then I removed C, this C and this C square plus X ABC. यहाँ तक कोई प्रॉब्लम नहीं है. What I got है ना, and then I can easily, मतलब जीरो निकालने का मेरा तरीका आसान हो गया. I can get my thing into zeros. कैसे? I can simply subtract these two rows. The first column can be replaced by C1 minus C2. तो क्या बन जाएगा? X minus X 0, right? And this column 2 can be replaced at C2 minus C3 0 X minus X, and this will remain as it is, A square B square. Clear or not clear? समझ में आया? और जीरो बन सकता है क्या? और जीरो बन सकता है तो बना लो, नहीं बन सकता तो सॉल्व कर दो. इन दोनों को जीरो ऐड करने से कुछ होगा क्या? ये जीरो, लेकिन फायदा क्या हुआ, ये फिर एक्स बन जाएगा, कोई फायदा है नहीं. ठीक है, सो नाउ यू कैन डू द कैलकुलेशन, है ना, यू कैन डू द कैलकुलेशन. सो दिस एक्स बिकम्स क्या देगा तुम्हें, सी स्क्वायर एक्स प्लस एक्स स्क्वायर प्लस बी स्क्वायर एक्स, एक मिनट माइनस ही रखो, क्या हुआ, माइनस बी स्क्वायर एक्स, यही है ना, तो प्लस बी स्क्वायर एक्स बन गया. ठीक है, यही हुआ, इससे तो कुछ फायदा है नहीं. और ये क्या हो गया, प्लस ए स्क्वायर इंटू क्या बचा, एक्स स्क्वायर, बस एक्स स्क्वायर बचा, है ना. तो कॉमन क्या है देखो, सी स्क्वायर एक्स स्क्वायर प्लस एक्स क्यूब प्लस बी स्क्वायर एक्स स्क्वायर प्लस ए स्क्वायर एक्स स्क्वायर, राइट. सो व्हाट आई कैन टेक आउट इज एक्स स्क्वायर. एक्स स्क्वायर कॉमन निकल के आया, क्या बचा अंदर, ए स्क्वायर प्लस बी स्क्वायर प्लस सी स्क्वायर प्लस एक्स. सो इट इज डिविजिबल बाय एक्स स्क्वायर एंड ऑल्सो डिविजिबल बाय ए स्क्वायर प्लस बी स्क्वायर प्लस सी स्क्वायर प्लस एक्स. अच्छा वहां माइनस लिखा हुआ है, अच्छा वहां प्लस होता तो मोर देन वन चॉइस करेक्ट हो जाता. क्लियर और नॉट क्लियर? तो whenever you see the symmetric matrix, what you have to do, you have to do a smart way of finding how to create balancing it. तो symmetry है तो आपको rows और column के बीच में play on करना है. तो you can multiply certain thing on the row and take out certain thing from the column to break the symmetry. Right? Understood? Good? Okay then, bye bye.